This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe think tank.
The Fringe think tank it is then. Now let's give them back their destiny and open it up to the world.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds. And, man, it's going to be a fun show. What's going on, Ben?
What's up, everybody? Just setting up my camera.
We're going to talk a little bit about a gravity well, Ben.
Oh, I hope I don't get sucked in it. That's one hole I don't want.
Nice.
But no, I'm really fascinated by this concept. I know it's like your wheelhouse, so I'm excited to learn more.
Right on. Well, let's take a look and see what physics thinks about it, Ben. What do you think?
I mean, it's a rudimentary concept that I guess is easy to explain to people, analogy-wise, but I don't think it's the full picture.
They built an expensive funnel.
Yeah. But in terms of the physics of how, gravity works, I don't think it's encapsulating everything.
Yeah. I'm sorry, guys. I was doing research for the show, and I looked up gravity well, and this is what they said over and over and over again.
This is what you found with what?
This is apparently what the thinking is. You know what I mean?
Oh, my God. We got our work cut out for us.
Oh, yeah, here we go. A little bit of what do you...
Yeah. We need Phil in the background with the middle finger.
I mean, like, seriously. Dude, we are so screwed, man. It's over for us if this is what we think. Like, oh, this is bad. Maybe they thought it was a gravity well toilet.
I think what's going on here is that we're seeing more of like what we see with magnets. You know, we're describing what's happening, but it's not explaining what's going on, you know?
Yeah, like, no, I mean, they explain it.
It does look like a toilet. It's a toilet.
It looks like a crapper, doesn't it? Oh, man, I had to, Ben. There was no way of getting around this. Look,
hey, that's the real physics bowl.
Okay. Yeah. So I looked at this and I go, look, isn't this the greatest picture, right? And then I read the comment on it. So look, the flat earth is right in the center of it. And I'm like, what the? Seriously? Flat earth suspended in the center of the toroidal fields. Like, who wrote this?
I was sent something by one of my family members from something, I think it was on Rumble. Somebody was talking about flat earth and literally no proof, just like, there's no such thing as stars. They're fixed. He's pretty much describing us as being in a snow globe. And I'm like, what the? Like, I did not have any words to describe the frustration of hearing what I was hearing.
I'm going, yeah, I don't know what to say. Like, the rest of it looks good, right? You got two toruses. You got you know what I mean? You got your funnels at the top and bottom. You have the field going around. You have your initial inner field. And then in the center, you got what most of us would just say is the ether, right? Until you get to the flat earth portion of this, it looked great.
So what I think this is a part of, and this could be just, ignorance as well, but I think this is a part of a disinformation campaign, because we have real, actual groundbreaking discoveries coming out regarding, like plasmoids and toroidal structures, right? And then it's mixed with this, so people immediately think it's ridiculous. So, that's what I think is going on here. And then people, who are susceptible to some of that, like, my family member who sent me the video, are actually believing some of this crap without any, evidence or proof.
Yeah, Ben, it's bad.
It's bad out there, man.
I mean, just some of it's kind of dumb, right? If you say we've never been to the moon, get out a telescope or go to one of these high-powered telescope places and actually ask them to look and see if there's a flag there. Did we leave some junk on there? We left a car on there, didn't we? And some of these things that they say in space. So there's got to be evidence that's there, right? So
right, but even so, right, even so, there's a difference between arguing that we didn't go to the moon and arguing the Earth is flat. I think one of them is slightly debatable. The other one is not even remotely so.
Well. I mean, I guess if your telescope's lying to you, maybe. You know what I mean?
Well, I'm just arguing from a devil's advocate point of view. Like there's more evidence to support, or there's less evidence to support the Earth is flat than anything, because we're the only celestial body in the entire universe that's flat and everything else is round. That makes no sense. Like I don't know. Maybe I just don't. Maybe I'm too stupid to understand the flat Earth theory. But
well, like this, they all think this is progress, and this is what?
No, this is going backwards.
20% efficient. That's our progress.
I mean, if we can get like the solar panels that were coming out, that were like 40-50% efficient or more, then we're talking. That's more practical solution. But this is. Yeah, we're barely reaching 20% on some of these, and it's we have to build huge farms just to get a tiny fraction of what is easily already there.
Yeah, I think it's absolutely hilarious, man. Oh, sorry, I'm putting up some of the comments in here. Anyway, yeah, look, I'll tell you why they think it's flat Earth. I'll just be very honest with you, Ben. Here we go. This right here. This is what they are showing people and saying this is the physics of gravity, right? So all the flat earthers see is this big flat plane, and they go, hey, that must be what we live on, right? So there must be gravity on this big flat plane. Otherwise, their head is stuck so far on the wrong end, I don't know what to say. Because that would be the only explanation.
Yeah, it's like a combination of different, that, and maybe, some people are saying, oh, because you can't see the curvature of the Earth, and you can if you're in an airplane. I've been in many airplanes. You can clearly see the curvature of the Earth.
Oh, yeah, absolutely.
But then the explanation that I've heard from some of these people who are literally insane, in my opinion, is, oh, they're screens in all airplanes that deceive you and making you believe. Like, I'm just like, what? Are you effing kidding me? Like, there was literally air kind of leaking out of one of the windows that I was in. I know that I'm being, the cabin is being depressurized or whatever, because of the way that it feels with your ears popping. Like, you can't, like, I'm sorry, like, you can't. You could fake something so far, but you can't, make me believe I wasn't in the sky in an airplane. That's just ridiculous. You could feel yourself coming down from, landing.
All right, so let's move into a little bit of something that might actually get us somewhat close, a little bit closer. At least it would be an experiment worth trying. So basically what we have here, Ben, is 3 spheres. And what we're basically looking for is, can you make the energy in the center go all the way out to the outside, which is not a problem if you use the negative energy that I work with. It's like a gas almost in the way it pushes out. So it's radiant energy back and forth, and it causes cavitation that goes on in between all the layers, which creates a positive and negative layer to every one of them. And then you get gravitics, and it's not in every single spot. Just like if you put a magnet on there, it only goes so far, but when in rotation, it creates a field, right? So you're going to get a harmonious field to every one of them, but we're not feeling the gravitic field right there on the surface. We're only feeling the saturation level. So I think this is more of what we're looking for in order for a first try. You know what I mean? Into this. By no means is it the end, but it's definitely an experiment worth trying. What do you think, Ben?
So whose drawing is this? Where did you find this?
I just found it on the internet. You know, looking through stuff, found cool experiments.
I was just wondering if this is some kind of device used
Well,
to maybe generate gravity.
that's kind of the point, isn't it?
Mm-hmm.
It is. We don't know the answer to it just yet. We all have a theory, and I've seen multiple papers by multiple people on theories of it, from everywhere from the fringe to regular scientists, and they just don't have an understanding of it. All they know is the earth is round and that, you know, something's going on underneath it and something goes on above it. And they have more definitions for the above stuff, which is understandable. You know what I mean?
Well, my initial instinct, knowing that the universe operates as fractals of itself, is that if you want to get to the secret behind gravity, or black holes rather, then you have to look into cavitation, you know, and plasmoid clusters, because they essentially act as the same thing on the micro scale and the macro scale, you know. And then something that Marco Rodin likes to emphasize is, you know, why does the hole exist in a black hole in the first place? You know, if it was actually condensing things so much, it wouldn't have a hole. It would just be compressing, right? There's something theoretically he thinks radiating out of that hole, which, you know, could be this cosmic radiant energy or 0 point energy, whatever you call it, that's causing it to not close. So that's an interesting thing to think about when you're considering gravity wells and creating gravity. I think it's all related, you know.
Well, let me say it this way. So rotating stuff like this, people, the first thing they would think is you're going to get a magnetic field, right? Which you probably will, depending on the magnets you put in there. I'll give you that. Look at it a little different.
Charges too.
Yeah. So you look at it a little different. You go, okay, like a dryer, you get a static field that sometimes gets in there and they try to stop it. But we all know as soon as you pull your stuff out of the dryer, it's static clean together sometimes.
Right.
So you get both of those type of fields, but this deals a little more directly in what we're looking for. The rod down the center has a ball on it. And
oh yeah, look at that. That does.
Yeah, the idea here was never to use the magnetics as the primary part of the field. It's the understanding of cavitation inside of magnetics. So if they say it's a molten core, right? Then most people would say, well, then heat up the center of it, right? Like an iron core, and let's find out what happens to the magnets. And then quickly they're going to find out they're going to demagnetize half the whole thing and waste all the material, you know what I mean, completely. What if you actually just put radiant energy in there? So we know we have radiant energy in the sky, right? And we know it's positive, it's hot. What if we simply put maybe hot and cold radiant energy in the center? You know what I mean? We can make them swirl each other however you want.
But like a yin and yang situation, like a balance.
Yeah. But wouldn't that be more of an energy because it passes through all the outer layers? Like, let me give you a for instance right now. I could take the cold energy out of the center of my Tesla coil and I can put it in any one of these parts, right? And it'll blow right through the whole thing. I can make this thing out of solid steel on each ring. It'll still blow right through it.
So you're creating different cavities inside each other with different charges. And then you're creating this energy that's swirling around, maybe, you know, to have act as a push off.
So in some instances, you get a magnetic field, and in some instances, you get a static field. You know what I mean? So the only difference is the amount of heat in that area.
The temperature, yeah.
So that's pretty much it. But we know that we want something when saturated, just like your clothes are in the dryer, we want it to cling. But we also know that we don't want it to overly cling. So it cannot be static electricity to build it out of. You're going to have to build it out of a radiant energy. So that, static electricity goes out. Magnetism, we know that it saturates, but it pulls in only things that are actually magnetic to it, right? Ferromagnetic. We need an energy that'll change and flip fields on on a dime, so that we can convert when we go through each cavity in order to get to the end, to have something that pulls in, but lets loose as it goes further out.
Like a cold current.
Yeah. Hi, Lulu.
Hey, what's going on, Lulu? Everybody's here today. We got Mike Does in the house. Ulysses is here. Good to see you, Cody. Elias. Everybody's here.
Here we go. Spin the fields, not the materials. So what do you think about that? Just take the inside of it and spin that and see what we get.
It could have the same effect. Honestly, I mean, it could just be an easier way of achieving the same thing, right? Huh.
I don't think anybody, by the way, likes the magnets. Yeah, so what I'm looking for here, Ben, in doing this, we always hear about the ether. We always hear about spinning toruses, and we always, between the rodent coils that we build, the geometry coils, and to a very, very small, lesser extent, the Tesla coil, we're looking for rotational fields.
Yeah, there's all these patterns. There's repeating patterns that we keep seeing over and over again, and yeah, rotating fields or counter rotating fields is a common one.
Yeah, so when we look at it as energy being put into the center, and then they're rotating, and that's what history tells us everywhere, that we have counter rotating fields going on somewhere. So 2 in the center would be perfect. A motor on top and bottom. We can make each one, go 180 degrees out of each other. But the whole idea is, what kind of energy do we want to put on them? It's fairly simple. We could just take the motor shaft itself and put the energy right onto it. And all we got to do to protect the motor is put a piece of plastic in between and the motor and the shaft. That's fairly easy. We can isolate that. Then when we put the rotating energy 180 degrees out from each other, that's fairly simple. All we have to do is put the ball and then create a little arm to it like that. You know what I mean? Just like a little L, and then have it come down, and then it spins just like this, which would be fine. But I think that's achievable inside of this. Now, do we just want everything there to be on bearings, or are we looking to engage it at some point? Do we want to put in some gearing in this? So I guess the first viable test is, let's run the energies. I'll just take the outside of my Tesla coil, throw it on one side, put the inside of my Tesla coil, put it on the other. I got a yin and a yang. Let's run it, see what it does. If it does nothing, we pop our magnets in. You know what I mean? Then we rotate it and see what the fields do to it. And then we can always make the balls themselves as a dielectric. You know what I mean? We can just simply put static electricity in there when we build each one of them, if that's what you guys want to do, or an electret, I should say. That might be interesting. I think we have to throw everything at the wall and see what sticks.
Are you actually planning on building one of these, or trying to?
Yeah.
That's awesome. That's so cool. No, I'm really interested. I thought we were just all theory today, and now you're just like, oh, I'm gonna build one of these or try to. That'd be cool.
Well, we're going to find out, right? I mean, I'm about finished with my Tesla coils for as far as I really want to go with it right now. I know we want to work on a little over unity with it later on, but I'm not particularly interested in flipping that cold energy. I want to play with it some more. This gives me like the perfect thing to do it. And I've already got basically this setup sitting here. You know what I mean? I could 3D print this sucker and have it ready, within a week for actual testing. We just got to decide how each part wants to work.
Right. No, you're going to have a new saying after that. Fly it and find out.
Oh, yeah. Well, look, I can see this right now. On the outside, it's going to have static electricity. I almost guarantee I'm going to nail that one. So what I'm wondering is what else comes out of it.
Yeah, I don't know. There's really no way to tell until you start experimenting. It's like you always said, you can theorize as much as you want about this stuff, but until you get your hands dirty, you really don't know what's going to happen. I mean, you can kind of prepare, but I mean, yeah, to be honest, you probably have a good idea of what it is capable of, but you still, yeah, like just theorizing about it, you could be completely, like surprised by some of your results, like we all have been with our experiments. So I don't know, it's exciting prospect. I'm excited to hear more about this device. I don't know what you want to call it, but it looks cool.
Yeah, I think honestly, Ben, one of the things I want to look at also in this is how magnetic fields build in a sphere shape, but then you have multiple magnetic fields. So in each layer, you have a magnetic field. So we basically understand magnetic fields. You spin them, the first, 3/4 of an inch is really good magnetism. And then you go out from there, probably, 4 inches? And then it drops off. And then, so on and so forth, depending on the speed that you run this thing at, like maybe 1,600 RPMs or something, you can really get some good fields. Now, how do they interact and build together?
Yeah, that would be interesting. I mean, you're building cavitation inside, the fields inside one another like that and separating the charges. Yeah, I couldn't say what it's capable of, honestly. But I can tell you that over unity is a possibility, because separation of charges is something that you would need.
Well, even if it doesn't do anything over unity, I don't know that I'd go there just yet.
Yeah. No, yeah, of course.
We just want to see what happens with the fields, because I'm curious in the fact that it's rotating a ball itself, right? Or a sphere shape. So, now, hold on. Let me finish my thought real quick. Even though we don't see it on here, will it build a dipole for north? You know what I mean? Or will it build north and south poles is what I should say. And will it vortex on the north and south just with the energy, not the rest of the structure, but just will the energy force out that way?
So, assuming we had this thing built, what kind of tests would you run to test, the fields? Like, run me through a couple of tests that you would be doing to determine this stuff.
So basically, the first obvious test, does anything stick to it? I mean,
okay, yeah, that's pretty good.
I mean, that's kind of the basic obvious thing. I mean, if we create this, can we, maybe not on the outside rotating magnets, maybe have a layer of something that's real thin that we could put around it and see if anything clings or anything goes to it. Can we get a dryer sheet to hang on the outside of it? You go, okay.
Yeah, something non-magnetic, right?
Yeah.
Yeah.
And then the next step would be, let's check the fields out themselves. Let's take a tri-field meter and let's take a look at everything that's on it. Let's take our static meter and let's check that out. And let's see exactly if we have any buildup of static on any part of it. You know what I mean? Let's check the surrounding area of it, of the frame itself on the outside of the build. let's see exactly what is going on there. If that's getting static electricity, if that's getting magnetism, is it, is there any energy there?
Or is it maybe like a null zone or grounded out or whatever? Maybe
Yeah.
it's not being affected at all. Yeah.
So the next step is we build that radiant field with the Tesla coil. I've rotated it. Okay. In some of my experiments with my Graviflyer, I don't know that anybody else really understands that. So it builds out like a field of gas and it just goes through everything. So when you do it in that way, it's hot, you know what I mean? Doing the wire on the outside, but then the rod down the center, it's always cold. So that builds out as well. Now it's creating mesh layers, right? That's what I'm so curious about. I don't think that we have to put in the form of a funnel on the top and bottom in order to get that electricity to funnel that way. Does that make sense?
I think you're right. No, I think you're right. Just the cavitation and the shape. Yeah, I think you're right on that.
Yeah, if you have a PDF on this device, it'd be interesting. I would love to know what they were originally doing with it.
Yes, Elias, that would be very kind of you if you could provide us with some of that.
So another thing would be simply, do we need to put the energy in the center the way that I'm thinking? Do we just need to say, okay, let's go basic old school. Let's just positively charge one side, negatively charge the other on, maybe a ZVS with a DC flyback or AC flyback, whichever you prefer. You know what I mean? Just build a little voltage on it and see what it does. We could do that as well. Yeah. Okay, sorry, I'm a little lagging in the comments here, guys. I don't know the name of this thing. I just have the picture. I just thought it was so interesting to look at.
Yeah. I've never seen it before.
So, real quick, I'll drop my email.
Yeah, Elias, Nathan will put his email in the chat. Much obliged, sir.
So there's mine, guys. If you need to get a hold of me, if you have something on this, yeah. Check your previous comment. Yes, it would be nice. That was the previous comment. See if you had another one. These devices seems to have 3 spheres, so 3 fields, which are the Earth's 3 fields. Well, that'd be interesting, wouldn't it? So there'd actually probably be 4 fields here. If you think about it, the center itself, whatever you put in there is going to create a field. Then the first ball would be a field, the second and third. So there's 4 fields there.
Yeah, you're just not seeing the one in the very center, the energy that's going to be created, you're saying?
Yeah, it's because you're basically producing it there, so it probably doesn't consider that the field, but it actually really is.
Interesting.
I'd be curious to see if it has a north and a south pole as we do it.
Yeah, that would be real. That was my question. Is like, is it going to be producing a monopole maybe, or a north and south? Is it going to be, alternating?
Yeah, one for control. Nice. Thank you. Yeah, I think honestly, Ben, we can either look at stuff that mimics what we see, or we could just build something.
Yeah, let's just build it. That's what I say. Let's build it.
I mean, mechanically looking at this, it's really not hard. It's just about bearings. It's about, building halves on this. And on a 3D printer, that's pretty easy, man. The question's going to be, what do you want to put on it? So say we make it plastic, right?
Well, about what size are we talking about for the base? These base plates, the top and bottom.
Well, the outside would be like wood and stuff like that. So that'd be whatever size. The inside, no more than 12 inches on the big one. on the
Oh,
outside
okay.
sphere.
Yeah, that's not too bad. That's
That
not
way
too
we
bad.
could just,
Yeah.
I could throw it on one of my CR10s. So probably like what, 11 inches or something. And then
About
we'll go in, we'll look for
mm,
we'll see if we have anything that matches that on sizes. You know what I mean? On harmonics. Because
right.
I don't want to screw that up because I think it's going to become very, very important when we go from plastic to any kind of metal in it. I think our
Yeah.
harmonics might be really, you know what I mean, come into play.
No, I think you're right. That's absolutely right. I think you're right onto something there. And it's something I didn't consider either. Yeah. And a plastic is a dielectric, so it doesn't, conduct electricity. It might not vibrate, the same way as metal. So that's a very important consideration. Yeah, I mean, I always try to, when I'm questioning things and I'm getting stuck, I always try to go back to Tesla and what he said: energy, frequency, and vibration. It's all about energy, frequency, and vibration. And things are always vibrating, whether we can see it or feel it or not, and something that just kind of hit me in that respect just the other day was, I'm getting black wasps in my apartment from time to time, and it's the dead of winter, right? I shouldn't be getting black wasps unless maybe there's a small hive in like the maintenance shed next to my apartment that's attached to it, and they're getting pissed off about the humming coming from my lightning thief device. No, and I looked it up, and certain vibrations and frequencies can piss them off, and they'll get, and I saw like wings inside the 40-watt LED panel, like inside the case. I'm like, it's like getting pissed off trying to fight it or something. I don't know. That was my
Gotcha.
theory. But yeah, no, it's like everything goes back to, energy, frequency, and vibration. Everything's affected by it.
Mm-hmm. So what I'm looking at is, we can run, by the way, each one in each layer and build it out that way. So just run the center one, put all the testing in on it, then run, each one individually and see what it does based on the size of it. We can also, so I can make a couple of these probably because we're going to end up needing them if we're, you know what I mean, to build this thing out properly. The other thing I was going to say was we can look at copper tape. It's real quick, real easy, and it'll, you know what I mean, build up energy on it. You could build static on it. We can build electricity on it. Each one of those things will heat up a little bit. So that's pretty good too.
Yeah. Yeah, I agree. And, it doesn't look like it's overly complicated. It looks like it's pretty straightforward and easy to set up to build, You got a, simple housing, and then you got, like a rod down the center that's, or technically two rods. A small, what is that, a motor on top?
Yeah, motor on top, motor on bottom.
Bottom. Yeah, it doesn't look overly complicated. It looks simple. Honestly, it looks stupidly simple.
Well, isn't that the point though? You take the
Yeah.
simplest stuff and you put the most complex methods in it as you build it based on, you know what I mean, materials and stuff like that, and then see what it does.
Well, no, absolutely, because you want it to be like if you do something and it does something unique, you want somebody to easily be able to replicate it, So, and that's key. Like if there's no use in building the Geet machine that's extremely complicated and overly complex, the average tinkerer, garage engineer can't really put together something like that. Whereas, something like this is very, rudimentary and pretty straightforward. I always said the secrets of the universe are going to be irrelevant unless they're understood by everybody,
Yeah.
So if the secrets of the universe are only understood by, a tiny esoteric group of people, there's no real point in trying to unravel them.
Well, let me just say this. I like to feel like we're going to learn some of them.
Yeah.
We didn't start this whole thing to not learn. You know what I mean?
Oh no, yeah, no, that's my point. Yeah, I feel the complete opposite. I think that we do have the ability to explain some of these complex phenomenon to a simplified analogy, or with simplified analogies, to a general audience who's maybe not like in the world of science but interested.
Yeah. I think part of the understanding is building this thing. You got to remember,
Yeah.
anything in rotation will make magnets fly. So you'll have to build it so that they pop in underneath on the inside. You know what I mean? That's something that most people probably wouldn't think about.
Right.
Then, do you want round magnets? That seems like the easiest thing, but did you want, cubed, squared? I think
Right. There's a lot of consideration to that, like different variables that you can tweak the machine. Wow. Yeah. Like what kind of material you're going to make the tubes with, the rods.
well, I would imagine, okay, in just my opinion, I'd put PVC down and then use a metal shaft or hopefully a stainless steel shaft in there.
Smart, yeah.
So that might work out pretty good. But
No,
then
that's
again,
smart.
because we want to ramp this thing up pretty fast. If the world's turning super fast, we might as well ramp this thing up and see what it does. I mean, look, let me just be honest. Okay, sorry, wrong hand. I will make this thing go as fast as humanly possible. I swear. Okay, just understand that when it gets to my area, I force everything to go as fast as it can, take as much voltage as it can, and see exactly how far you can push it before it breaks.
Nice.
So,
well, I'm definitely excited to see what it's going to look like.
yeah, I got a set of DC motors here right now. So I don't want to use anything that's going to break right away. Like,
Yeah.
I want to stay away from like RC car motors that are not just straight DC. So if it's brushless DC, I want to stay away from those. I don't want any failure going on there.
Yeah, because it has to be spinning really fast, and then it can't have any failure. While it has to be continuously running.
Yeah. I mean, I'm sorry I've used those brushless DCs. As soon as they get into high voltage after a while, they don't sync up anymore because they're based on frequencies. And you throw rough frequencies in there, you know what I mean? They get all messed up.
No, DC is probably the best route. Some of those DC motors, they'll keep on running.
Well, yeah, I mean, 3,000 RPM would be pretty good, right? I mean, we could get one of those out of the motor, one of the motors I have sitting over here.
Yeah.
So I got a set of them, so we can do that.
Yeah, we've seen what you're capable of with the high-powered motors in the Graviflyer. So this thing is gonna spin. This thing is like it might be dangerous. You might have to wear a helmet. So wear your PPE, Nathan.
Oh man, yeah, maybe. Well, if something comes off in the center of it, man, it's going to create one big ruckus. That's for sure. So, yeah, I'm thinking just do like half spheres on the. Sorry, with dentures, it's hard to say S or sound out S. With the spheres, I'll do half of them. Half and half. Put a notch in there so there's a male and female end to it, so they connect together. Then we can glue them with PLA glue. They should stay together fairly well. So once it's set, it's set. We'd have energy coming in top and bottom that we can control. So, you know what I mean? We could change the different types of energy on that. But I think that's the way to go. And then we'll set up one where we can take the sphere off and just run one and run two. You know what I mean? We might have to build a few of these, but yeah, I think we're going to be better off. Yeah. It'll at least give us a bunch of data. I mean, think about this. If we run that, Tesla coil field on this, and you get the hot side and the cold side interacting, what is it going to do? I've never done that. So that's always super interesting.
Yeah, I don't think a lot of people have done that.
Crazy. Yeah. But by the way, Ben, the rodent coil you have on your original green one.
Yes, the Mark I.
It's got that groove in it. And I was looking at it just the other day. I'm going to expand that the size of that groove.
Oh, make it for housing for the pickup coil.
That's right.
Nice. No, I know exactly what you're talking about. That's going to be I didn't even think about that. That's genius.
Yeah.
Brilliant.
I just got to throw it in the CAD and you know what I mean, reshape it and you know what I mean, fix it up and then print it out. And I think we're going to be good, man. I think that's going to be awesome for that. I didn't want to forget to tell you that.
No, that's awesome. I did also get the replacement display board for the Creality CR10. But it is giving me a temperature halt error for the bed. I know it's not the sensor, so maybe I accidentally disconnected something when I took it apart. I'm not sure. I'll have to check. I don't think it's a firmware issue, but it's not exactly the same board.
I'll have to look at it, Ben, because it's usually just the sensor that goes to the head on the 3D printer.
Yeah, no, it is. It's just one wire, but I think, when you take out the power supply, I think I'm going to check. I'm going to check tonight. I might have accidentally unhooked one of the pins back there.
Oh, yeah.
And that might be what it, just got disconnected. I'm hoping that's what it is. I hope I don't have to update the firmware.
Yeah. Okay. All right. We'll talk about that one later, Ben. Yeah. Firmware, by the way, you don't ever need to touch.
That's what that's...
just stay away from that. You know what I mean? Stay completely away from it. You'll end up with broken parts.
That was my instinct on that. I wanted to run it by you before I did anything because it was frustrating, but I almost got it working. So, but yeah.
Okay. All right, I'll look it up when we're done here, Ben, and just shoot you an email on it. All right, Let's get back to this thing right here. All right, so go ahead.
Oh, what are we calling this, by the way? What are you calling this? Like the gravity well device?
Yeah, I guess maybe with a couple question marks at the end. You know what I mean?
Yeah.
I don't want to name it something like that, and then all of a sudden it's poo on creating any kind of gravity. You know what I mean? That pretty much suck.
Project Gravity Well. Okay.
There you go. I like that. Project Gravity Well gives everybody knows they're a project. You know what I mean?
Yeah, it's not an official device. You're just experimenting with it to see what it's capable of.
Yeah, I think maybe we should get some of those magnetic sheets and see what it actually does. A cool thing would be with that route side ring right there is to get a couple and put it on there and see if we can't get a 3D view of what's going on. You know what I mean? Like, you know what I'm talking about, right? They have these little sheets that are about this big, and you place your magnet on it, it tells you the field, right? Do you think when we rotate it, we can pick up any field on one of those? You know what I mean? Or
maybe
even if we took, ferrofluid or magnetic fluid, whatever you want to say it is, we could put that in there and we know it moved, but which way is it going to move? You know what I mean? I would say mercury, but I don't play with that stuff. So that's out for me. Somebody else can take that experiment up.
Yeah, I was also going to bring up mercury, but I mean, we know it from the ancient texts, but it's not the best stuff to work with.
Yeah, but I think it'd be fairly easy to get this device, within a week, get it to build out, see what it does. And then what I'm kind of excited about it is if Sean creates that electret and we could put it into one of these, things right here as we build it, I'm super excited to see what that does. Then if we could put water in here and maybe just a cavity somewhere on it, on any one of these spheres, and then rotate that would be cool. You know what I mean? Because then energy going through water, what does it do? We know that it doesn't like the mineral oil, doesn't like to go through that. It probably hates going through some tar, but things like that would be interesting in there. So maybe,
or even like little tiny drops of water. I don't know, because I'm thinking the acoustic levitation phenomenon. If you didn't have a small enough particle or material to put in that null zone, that node,
Yeah.
then you would never know that node existed, right?
Mm-hmm.
So, maybe play around with the size of the stuff that you're putting in the little drops of water. It could be doing something. Who knows?
Yeah. Well, I agree with there.
Mm-hmm.
That'd be really cool. I want to see mostly on the outside sphere, right?
Outside sphere. Yeah. The question that I was going to have is how big is the field going to get? And if it is cavitating different fields inside, like, are you able to determine how big the ones inside that big field are too? So those are questions that I would have, but there's only one way to find out.
Well, I'm hoping, and this would be one of the biggest hopes of this whole thing. If the inside sphere takes a position of like static, we'll just say static for now, that it holds something in, right? And then it pulls on the second sphere that goes onto it, right? Then it pulls on the third one. I want to see if it's going to do that. That way, if it does create any field on the outside, even if we can't see it, we know that we got some kind of pull, and then there's going to be a push when it gets to the outside. We know absolutely it's going to fly out, right? So that's what I'm curious about. Will it pull in on any one of those layers and give us that gravity we're looking for?
Yeah, that very well is possible. I'm optimistic we'll get some positive results with it if assuming that the device isn't too difficult to put together. It doesn't look like too difficult.
No, I don't. Temperature readings. We got to set up something for temperature readings. Absolutely correct.
Yeah, that's a good
because
point.
we got to know which one's hot and cold, right?
Right. Yeah, like a thermal camera, maybe.
Yeah, I got one of those. We could do that. Yeah, that's going to be interesting because if you put different materials on there, do they shine, right? Like, for instance, the brass shines right through my Tesla coil. So that'd be interesting to find out as well.
Yeah, there's a bunch of tests we could definitely run. I don't know. How long do you think it would take you to put together something like this?
Like I said, about a week.
About a week?
I mean, look, we're talking going into CAD and building round balls. I mean, that's not really difficult. They have the program for that. All we got to do is when we print it out is where do we put, everything at? Like the bearings, what size are they going to be? How do we want to work that out? Do we want them all directly connected where we make cause fields on the bearings themselves that we didn't want? You know what I mean? Or is that going to help us if we left them in there? Do you get what I'm saying? So some of the stuff has to be isolated. Sometimes it's great never to isolate anything and just find out and then go from there. I couldn't tell you right away, but I know we can get something spinning within a week.
Yeah. And well, the main concern with something like this from an engineering perspective is you want to be able to build it so it doesn't vibrate itself apart. So, all those things are stuff that we have to consider. Yeah.
Yeah, there you go. Centrifugal versus attraction. Everybody talks about it. You know what I mean? And what does that do? That's the most curious thing. I don't think this thing's going to lift off the ground, but you know what I mean? I think it's going to suck things into it. It's just the feeling you get, yeah?
Yeah, it might have some kind of, even if it's weak, like I said, like with little drops of water, you could still see maybe some kind of effect, hopefully. I don't know. Well, we'll find out. I think that'd be fun to work on a project like this.
Oh, yeah. Just so you guys know, I worked in Fusion 360 a lot. So I build everything in there, and I have a Thingiverse account, and I put all kinds of stuff on there for free, guys, for my Tesla coils. If you want any of those STLs, if you want any STLs for a computer fan, stuff like that, I do that. I made this really cool skull looking one. Just awesome stuff. Made a bunch for my daughter for her computer. Magic cards, I think it was. Magic the Gathering or something like that. It was pretty cool. Anyway, a bunch of that stuff on there.
Nice.
For all the projects that I do, I seem to put them on there. So let's see. Very small center, right? Yeah. So I'm thinking we got to have a center sphere, so it's all got to be on there tight too. That inside one, we can't have that malfunction because you're basically ripping the whole machine apart to get to it. So that may have to be, I don't know. It could start out as a standard rod with a rounded end. Anything with any threads on it, that may be out. It may have to have a locking pin on it. Just because if you rotate it, 4,500, miles per hour, it's that sucker's going to fly at some point. Unless it's a reverse thread, that might be okay. Reverse, you know what I mean? So that it tightens the faster it goes. I don't know. I'll have to work that one out and see exactly how we want to put that one on there. But yeah, we're gonna have to figure that. But that's we get a guy with a welder and weld on a ball on the end of a rod, and then we can shape the rod however we want to, and make it just the L shape, and then there's the ball welded on the end so it goes nowhere. But that'll also cause vibration. So I don't know. There's a lot of stuff to consider. But basic in the first one, test it out, see what it does without any spheres on it, see what it, how it performs, then start building it. That's my thought on it anyway. Three spheres, three motors. Static. Oh man, I should tell you on my gravity flyer, I ran. Okay, if you put two DC flybacks in series, by the way, on any rotational object that's metal, you will get a massive static field quickly. So, and then you take a dryer sheet and it's like torturing the poor thing, right? You go over to it and you put it in between like two plates, and then it starts to just spit it out like crazy, man. That's absolutely one of the most awesome things in the world. It will literally take you maybe 2 minutes to fill a room, and you'll have static electricity everywhere, and you could feel it. It gets thick in the air. So it's pretty cool. And then if you're in a super small room like a closet or something, man, good luck. That thing will make every bit of clothes in there, man. They'll all stick to you. So,
that'd be a hell of a prank to pull on someone. They go in their closet and everything sticks.
Might get a little freaked out by the high voltage and spitting off a little bit, but yeah. Check your email, found a few things. Right on, man. Let's take a look. I just think it's going to be fun, man. Nope, don't have anything yet. So we'll check back in just a little bit. Anyway, yeah, I think this device is definitely a build, and I think it has to happen. And because we have, kind of different energies than most people put in this, like, let me just say this. Most people would just look at this and they go, okay, let's put an AC field on a DC field. They go to maybe put a flyback field on there and see what happens. I don't think they would go that far, but you know what I mean? I could be wrong. So I hope I am. And they would try that. Me, let's put some real fields on it. You know what I mean? Let's take that, Tesla coil, the center of it, because once you break it with the rodent coil, you're not messing with the frequency of the coil all day. So now it just builds out like a set of gas. So now it's going to go through everything. And I don't care what kind of foil you put on there to stop the frequency. It's going right through it. I've tried it. I've tried to pin it in there, and it does not like it unless you put something on the outside like mineral oil. So yeah, I mean, that's going to go right through everything. So it's going to build a radiant field to the whole thing. And the outside of the Tesla coil, I keep saying it's scalar. Let's find out. then you know what I mean? I think the frequency is going to matter between each one of them, because as soon as you spin something that has metal on it, you're going to get a harmonic. And because you're going to build a frequency, you're going to build volts and amps. We're going to get all of it. If anything in there is, you know what I mean, copper tape or any kind of aluminum tape, we're going to create energy right on the surface of it. So very interesting stuff. Good luck with getting in balance with counter rotating, getting it rigid in the center. Well, I have an idea about that. I've done a lot of rotating devices. So I think as long as because you go, if they're two shafts, yeah, it's kind of a little more difficult than it is one, right? Probably what you're thinking. But I think that's all on how you build it. So if you build a bearing housing, say, you know, about 2 inches high on each side to make sure that it rotates correctly at all times, that might be a little easier. I don't think it's going to get out of whack because we're not going to go crazy on the weight. But I think that would, that right there would do it. And we'd be able to balance that rod pretty easily. So. So funny, guys. I love this. But by the way, Ben, real quick, I was watching Cold Energy on Michelle's channel.
Mm-hmm.
Did you see that one?
Yeah, the video he just uploaded.
Okay. So let me see. Do you have that? I want to show people that because it's interesting because he did it. The French guy who actually built that did it well before we ever did.
Yeah. Yeah. And he's going through and painstakingly transcribed some of his French writings so we can read. I haven't gotten a chance to read it yet, but it's something that I'm really excited to delve into because, you know, a lot of these, you know, esoteric science papers have been lost because, you know, they were in different languages and never were translated. So Michelle's been going around, and I got the video right here if you want me to put it up. And
yeah, absolutely.
I'll also drop Michelle's channel. His channel link in the chat as well, because I want to get more people to his channel. He only has 165 subscribers. He needs to get that up because he has some very important videos on there. And he is an important member of the team. And like always, we try to get the numbers up on other team members who are starting out, like Phil as well. I know we need to get his numbers up. So let's put Michelle's channel in the chat.
So the whole reason I wanted to show this video, Ben, is because here they were, scientists keep saying there's no cold energy, yet somebody keeps buying this stuff.
Yeah.
You know what I mean?
Yep. Yeah. I mean, it's frustrating, but I got the video right here if you want to. So I'll read the description real quick. This is a replication of a device released in the 80s by physics teacher and inventor Richard Viale. Mr. Viale released this information to the public domain, so his research cannot be patented and people can experiment and learn about cold current. Documents released by Mr. Viale to public domain and translated in English. Here is the link in the video. I'm going to put that in chat as well. So, yep. You want me to play it?
Yeah, if you don't mind, fast forward to a little bit of the
beginning, yeah.
The boring part.
No, it's fine. Let's get to I think it's right here. He's just showing the light for a few minutes. And then he kind of describes the device a little bit more here.
Cold and auto-generated.
You're gonna have to turn it up a lot or hit the closed caption.
Yeah, let me hit the closed caption because this is as loud as it goes, unfortunately.
This device was invented, created by Richard Vial. He was a physics
Sorry, Vial.
professor born in the 1940s, and he was a physics professor for 40 years. So pretty much most of his career.
All right, Ben, pause it real quick.
Very
Okay, let me just tell you what's going on here, guys, because you probably can't hear it very well. Basically, what he's creating there is 2 pieces of copper cut in half with a insulator in between them. Now he takes and he winds on this, how do I want to say it? It's just an insulated wire. He winds it in a counter rotating direction. Now, what he's doing is the 2 bolts on the end obviously are conductive to the rod, right? So he's canceling out the fields by putting 1 wire across both of them. So there's not really a north and south on it almost, but now he's putting the light there across both of them as well. Now he's going to put in AC sine wave into this. Go ahead and put it close to the end, Ben. There you go.
and we divide this by 300. This would really be the amount of voltage that you would get in this wire. Okay, so I'm ready to test this experiment of Richard Vial, and he invented this device called the l'autogénérateur, which is a generator, automatic generator. That's the translation. So I'm currently set on sine wave, and the frequency is at 5.62 megahertz. Amplitude is 25 volts. And I'm gonna turn on the channel 2 here that you can see on the screen, and we'll see what happens to the light bulb. You will see that indeed the light bulb will actually turn on, surprisingly enough. I'm just going to turn off the light for this experiment here. I'm also going to turn off the screens. Okay, so we can see here the light bulb is off. I'm going to turn on the function generator. And lo and behold, there is power in the light bulb. So the frequency here, we are at 5.62 megahertz at 25 volt peak to peak. I hope you've enjoyed this experiment of the first replication of a device called l'autogénérateur of Professor Richard Vial.
So I think Michelle just sent me a text earlier. I read it briefly. I think it said something like this light might be producing some kind of different radiant glow. Like I know we discussed the lights glowing a little bit differently with this energy, with cold energy. So it's something interesting.
We've got, so what you're witnessing here is called cold current.
So do me a favor, Ben.
Mm-hmm.
Just scoot it back to the point where he shows the whole device.
And
okay. So just want everybody to notice the design here. We're taking a magnetic field on the outside with a sine wave, and we're putting a rod right down the center of it. Anybody seen that before where somebody describes cold electricity?
Yeah, that's Tesla.
Tesla, Don Smith.
Mm-hmm.
I do it in my Tesla coil. Every single one of them that comes up with cold energy always finds this. That's kind of something that we should all start looking at when we look at devices and how they're made. And if they're producing over unity, it's kind of a dead ringer for what you're doing.
Yeah. And this is a pretty simple replication. We can whip something like this up as long as I get the tubing pretty easily to try to replicate this. So it's just more proofs of concepts that cold energy exists. It is real, and we need to start looking more into it.
Yeah, do me a favor and drop the link to that video in the chat, Ben.
Oh yeah. Let me get that.
Yeah, because I think some people want to watch it in more detail, and I'm sorry, I kind of skipped through a lot of it.
No, it's fine. And to be honest, the audio is slightly low. So people, if they have the link, they can go on there and try to boost the audio on their own devices. I'm gonna talk to Michelle. Maybe I'll go over some tips for the microphone.
Yeah, sorry. Yeah, there's a break in the middle of it. Basically, he used electrical tape to break the two sides of the copper. So it's cut in half.
Right.
And personally, I would just use a rubber grommet from like a hose. And, the one you put in your hose so it doesn't leak. So I'd use one of those in the center. That way it's completely far apart, tape it a little bit and run all this over it. But it's basically the same thing as long as it doesn't conduct through it. I mean, everything on there is going to put out a field. So I always wonder in this experiment here, is the field reaching across in the center when the electricity is on? And I don't know if there's a way to detect that. Yeah. Maybe with a thermal camera you could see it. But
that might be the only way to see it.
Yeah, it's just interesting, man, because it's cold energy and people wonder why it's cold. It doesn't have heat loss. That's what you're looking for. Heat loss ruins everything. So, I mean, as soon as you start losing heat, you can't get over unity. You have to have something that doesn't have heat in it. And this circuit's probably cold, and it's probably one side's acting like a ground, so the light's pulling towards the ground. It's taking the energy it collects.
Yeah, heat is literally the byproduct of wasted energy. So it's a signature that you are getting waste. So you're right, it's decompression. You want the cold side, not the hot side, or at least you want to direct it in the system so you're not wasting it.
By the way, has anybody used cold electricity? Mike has a device that he uses, the Renegade device. It produces over unity right now. You can run it. It's a, what do they call that kind of motor? A pulse motor.
Yeah.
But it runs a cold energy circuit into it, so it's pulling energy in. So here's the thing. The understanding of it's very simple. Once you put the cold energy into it, it flips the field. And I say it's not static. I'll say it's not the magnetic. It's flipping the field. And the reason I say that is because when you beat Lenz's law, the only way to do that is to remove the part of the magnetization that creates the energy field around it. Once you put that into a coil and it's gone, and it's now just in a little piece like this in the very dead center, now when it goes around with the magnets, it actually puts the same amount of energy in there, but instead of it having any repulsive or sluggish feel or anything like that, it no longer has that because you beat Lenz's law. Now it spins as fast as you want and pulls in the energy.
That's when I use the Jewel Thief circuit on the coils, you don't get any. You get the efficiency with the lighting, but you don't get any magnetic field detected. And it's not that it's not possible to create a magnetic field. You're just, like you said, you're deactivating that component so that you can activate the other component.
That's right. So I think that's what people misunderstand all the time. So you put out a little bit of energy to flip the field, and then once that field's flipped, now it can gain all the extra energy you want it to. And It doesn't have a problem in converting it. We've been doing it on my channel with the soda can, man. I mean, Look, it's not that hard. If you know it's cold, you got to flip it back to hot.
Mhm.
That's fairly easy. You're looking at a temperature differential. So all you have to do is create the process. So, for instance, all I have to do to trip my breaker in my house is heat it up. And my breaker will trip, right? Well, that's kind of the same process here. All you have to do is find an item that'll heat it up. Once you heat it up, it flips the field. Then, once you stop heating it up, it flips it back. You see what I mean? So, yeah, it's fairly easy. And once you get to understanding that, now you can start playing with temperature in a whole system. Now the fun part begins. You see, you thought you were having fun before just creating the field. Now you can start to really mess with stuff. So, I mean, think about it. You got a field that you're running through you can take this off screen, Ben. You got this field going through a rotational coil. Then what happens to it? It pulls more of the cold inside, so you naturally get a vortex through it. That's the whole thing. As it gets colder, and it's not going to get a lot colder, it's just going to go below room temperature. As it gets colder, it'll store the energy in there because there's no heat loss to stop it from doing it. So every time it goes, it rotates, it's putting more energy on it. Every rotation of it, every time it spins, it's putting more and more energy into it. You're just playing with the environment of the room. You're not making more electricity. You're just pulling it in. So, I mean, it all depends on what your thing of over unity is. How do you want to define it? If the energy is already created, all you're doing is pulling it in. You're not necessarily building over unity. You're just using the energy in the room. You're just saying thank you for whatever is in the room, right? Not a hard understanding. I think it's fairly easy to understand. We've already built stuff like this, guys. I showed it on my channel. I can put this energy into a coil and energy will stay there for a while. Doesn't go away right away, which means it's continuously building energy, which means I've oversaturated that coil with energy that's a bit colder. So what does it do? It continues to put out the energy until I pull that energy too far that the saturation's gone. Exactly like the Joule Thief. It's no different. Still there, Ben?
Yeah, I had to grab the food out the oven real quick.
So yeah, that's why I'm excited about that whole other device, because when you find out this energy does that, and then you find out that you can put it in anything and it stays there, but it'll move. It'll move with the air in the room. So when I say it's like a gaseous state, and please understand this, I'm not calling it gas. I am saying that it's energy that builds out like a gas. So it has the tendency to do things that gas would, right? Or air. You can say either one. It has a tendency to move when you put it in a fan, right? So it'll swirl. There's no problem with that. The difference is it's thick enough to the air on the outside to create a field inside of it. See, that's the cool thing. So now we're going to take this thing and put it in a sphere, man, and we're going to hit it with all this energy. So what is it going to do? It's not just going to do this. I mean, it's going to have some massive fields that go around the whole way, and then it's going to throw it out 360 degrees. I mean, that's the cool part about it. We're going to really get some stuff moving here. Then, at any time that we put in that hot, it'll flip it. And then, you know what I mean? On the outside, I expect if we put water out there, we may be able to make that sucker boil. That'd be cool. Make our own little hot springs on the outside of it. And then maybe we'll just throw a little green army men at it and see if they stick. Make it black out, huh? Well, that'd be interesting. I've had a lot of things try to do that, and not one's done it since. So let's see. That's all about the flow of energy. Yeah, look, I'm a lot different than most people. I'll be honest with you. I do not sit there and think in a little box because I'm told rules. I try to break the box. That's the only way we're getting ahead, because if we haven't found it yet, you got to find some other way to find it, right? That's the only way you're going to do it. is push things to the extreme, see where it wants to flow, and then run it hard. So at least that's my understanding of things. Frequency directional. Now, that's the thing, right? I think it's going to grow out in spheres, the frequency, just like scalar. And then what it's going to do is probably build out in temperature just the same. That's my prediction, albeit my point of view. But that's kind of what I'm seeing in this, that it's going to go out in the field. So each field will go on the outside. It'll actually lose a little bit, right? So as it gets colder, the frequency should go up. But as it sits closer, the frequency will go down. It's no different than regular energy, right? If you don't know this by now, by watching my channel, you should. That frequency is real simple. You bring up the frequency, the volts go up, the amps go down. You bring down the frequency, the heat goes up, and the amps go down. The amps heat up, you pull down the frequency, you get more amps. That's the way it works, guys. It's real simple. You should know it by now, and it's a proven thing. I could pull up a video, in a minute and have that thing proven. So it's just pretty interesting because all you're messing with is duty cycle when you do it in your wires, and you're messing with the frequency. And we can all buy a $10 Amazon part that does that. So,
well, when I was messing with the frequency, trying to get the micro vortex coil and resonance going to a really low frequency because it's a very small device, I was trying to tune it or whatever. And the lower frequency that I went, the higher amperage draw from the power supply. So that's absolutely astute observation.
Well, hold on a minute. I'll just pull it up for you guys. Because it's interesting to see every once in a while.
Mm-hmm.
I don't think everybody's seen it yet. So give me a minute, Ben, and I'll have it for you. Sorry, I got a lot of videos on here, man. I'm trying to shuffle through. Here we go. Let's see where it is. Not that one. Should be right after that. There it is. Get it right over here to the good part.
My absolute favorite graph right there on the upper right corner.
What we got going on here?
Absolute favorite.
Right. So you notice what's happening here, right? You see how the frequency is changing, right? We have response there. Now let's look over here, right? So we initially dialed it up to 12 volts, but you can see we're just under 4 amps a draw, right? So when we actually change the pulse width, check this out. See that? See how the amps start dropping and the voltage rises, right? It's an inversion. All right, we'll go the other way. Notice the amps are rising, voltage is dropping, right? There's your duty cycle action. I haven't adjusted the voltage at all, okay? Now when we look at the frequency, what happens this time, right? As I go up in the frequency, the amperage drawn goes down, right? And there it is. You hear that? That's what we're talking about right there. He's totally right. There's a 5-to-1, okay? As we know, everything is connected. You can't just change one thing and expect to get something, isolated. Everything changes and moves with it. All right, so we're also looking at the actual resonant frequency of the the flyback system itself, right? So I'm changing the pulse width. You notice we've dropped in voltage, right? There's a raise in amperage, pulse width down, right? Raise in voltage, drop in amperage. See that? Now we're increasing the frequency. Now we're decreasing the frequency. Now you hear that, right? So we're coming out of the ultrasonic range, right? And this has a lot to do with the resonant frequency of our flyback, right? So everyone's slightly different. You got to kind of find your zone. So look where we're at right now. 8 grand, right? Let's take it all the way, right? So you see that now we're way high on the amperage, right? So we'll change the pulse width. Yep, wrong way, right? See that? Lowering of amperage, raising of voltage, right? You can hear it kind of slowing down. So yeah, highly recommend checking out Old Man Build's video on this particular subject. There is a lot going on, right? All right. Thanks, you guys, for watching.
So yeah, you guys can see it, man. As soon as you start messing with that stuff, this is why a lot of projects go awry. When you know, I mean, you don't really build things all the time, and you kind of put things in systems like you go, oh man, there was a little too much heat in that system, or you put it in a tube and don't realize, hey, you know, heat's going to create your amps and drive that up, and it's going to send your frequency haywire. I mean, I've seen a lot of different things in there, guys, that go wrong just because of that. That simple reason. That's it. If you understand voltage and amps and how they work back and forth with, you know what I mean, frequency, you start to really understand something unique here. Then your systems don't fail. You don't get haywire readings. You get the reading you're looking for. So anyway, I just thought that's pretty interesting. I always like to show that. I love it when somebody validates what I'm talking about. You know what I mean? If I haven't created it myself, or I have a cheaper version, he has a real good setup there to show that, and it really was cool. So I'll keep showing that, man. I think it's awesome.
Nice. These are not the readings you're looking for.
Yeah. You know how many times I've screwed up my whole system by not knowing that?
Yeah, I've done it plenty of times too, man. Don't get me wrong. I've screwed up plenty of times. Just last night, man. I hooked up a rectifier to try to rectify some of the extra energy coming out of the Lightning Thief system back into the battery. And I had it hooked up. And then for some reason, I think I accidentally switched the positive and negative terminal, and the rectifier started smoking.
Oh.
So
a little bit of find out, huh?
I did find out. I found out it was fucking working.
Wow. Yeah, well, I've done that.
I mean, it was working, so we're gonna try that again and see if it increases the efficiency at all. Because it was. I was getting on the O-scope, I was getting a major negative spike on the positive terminal. It was insane. Like, it was like there was almost nothing. And then I hook up the rectifier, and then it was like a huge negative spike on the positive terminal.
Oh, that's amazing. I love it.
I know, right? So cool.
Well, let me tell you something I did. I stupidly took AC and ran it straight to a full bridge rectifier without putting the transformer in the middle.
Oh, what does that do?
Oh, it just fries it. Yeah, it fries it. Yeah, I fried it. Fried it and fried it out. Yeah, right away. It's like, why did they put the transformer in there? I don't understand. Let me just run it without it. No. There's a reason. So, yeah, I've had a lot of those episodes in there. You get so excited, I spent days building some stuff, man, and it fries in minutes. Like,
yeah, you get excited and you forget, oh, this wire is hooked up wrong or this is disconnected.
yeah. Or you build an AC flyback, right? And you didn't look at any of the temperature on the wire that you bought. You didn't bother to look at the insulation temperature. You just said, I'll buy the cheapest one. So then you start wrapping this thing, right? It takes forever. And you finally get it wrapped. You're counting turns and your mind is almost gone. And then the whole event lasts like seconds. It's like immediately fried out because you took no time to look at exactly what the temperature was on that thing.
Hey, I've done that before. You don't look up something ahead of time. You just decide to wing it and you realize, probably should have looked that up.
Yeah. I started up my Tesla coil a little while back, just some mishaps and when you're doing stuff. I had forgot. Not only did I run the regular rod down the center, but I took an aluminum rod and put it over top of it, right? So it immediately creates hot energy. So I put it on my rodent coil and I'm all, man, something stinks around here. This isn't normal. So I start looking around and I go, oh man, let me just touch my rodent coil. And then it shocked the living daylights out of me. And I'm like, whoa, hold on. Hold on. I felt that shock before. What the heck is going on here? What did I do? So then I look, and then sure enough, there's an aluminum rod inside the rod of my Tesla coil, and I'm going, oh my God. How embarrassing.
It's the fringe scientific equivalent of leaving your zipper on down.
It's like you find out somebody goes, oh no, you can't flip it back. It's not hot energy anymore. And then you go, well, let me tell you, it really is. It gave me a good voltage jump. I'm only glad I didn't have it hooked into my bipolar Tesla coil at that time, because that one gave me a bigger shock.
Oh boy. Wow.
Oh. Yeah, that was fun. When you can pull over a 1-inch spark out of something that was cold electricity and you flipped it back to hot, you did something. And it all had to do with the frequencies. That coil was getting, it was probably, how do I want to say this, probably at a very poor resonance frequency to the main coil, but it was still resonant to it.
Oh, so it was not exactly in the exact sweet spot, but it was close to, like, it was within the resonance zone or whatever.
Yeah, it was like, say you look at your oscilloscope, right? And you got this little blip that looks like this, and you go, oh, well, that's just junk, right? I need something like this size in order to say there's resonance in there. Mm-hmm. Well, that little size right there was enough to put that extra bit of energy in there and just shock the living daylights out of me.
Oh, wow. Wow.
Oh, man. Oh, hold on. I haven't been in the chat at all, have I? Let me fix that. Oh, I haven't been messing around with the chat. There you go. Old man Bills. Getting in there. I love the chat, man. Well, getting in there and talking some smack a little bit. Throwing up some emojis in there. Fry everything, man, at least once. So, yeah, I was, God, man. I was trying to run those little RC motors, those brushless DC motors on my gravity flyer one time. And I had really put some high voltage in there. So I turned it up and I took my AC flyback. I took voltage multiplier and I put, oh my God, a whole bunch of voltage in there. So I hooked it to my battery, which is 24 volts. And then it has a lot of amps. So the drill battery you put in there. And let me just tell you, that voltage went everywhere. It was like, if it could touch you, you got it. If it could touch the center plate, it got it. Anything it could reach, it got. So I fried the motor. After I fried the outside metal parts of it, because they were close in at that time, right? So it's zapping the living daylights out of those and then hitting the bottom plate. And it got me a couple times, blew the heck out of that motor. It was smoking like crazy. Yeah. Good times, man. Good times.
It sounds like a fun time.
Well, that's why I have the big garage door. Just open it up and let all the smoke go out of it. You know what I mean? Let all the smell go out. If you didn't fry it, you didn't find out. So at least I know it can't handle that kind of voltage.
Have a mirror in there so you can see if all your hair's standing up.
But by the way, when I ran that voltage multiplier, Ben, that's the distance I was getting out of it. Okay, from point to point. So you can imagine how much voltage that was in there, and it was white. It wasn't, like thin purple voltage. It was white in there, man. It had some amps.
Wow. Yeah, it wasn't. It wasn't no. Luke Skywalker lightsaber. It was a white one. What do you call that? What was that? The white lightsaber. It was like the most special lightsaber.
I don't know, man. Any more energy, and I would have made a white hole out of it.
Yeah, the white signifies like a hell of a lot of energy.
Oh, man.
Didn't you say you got some kind of, was it a white glow before on like a wire?
Oh, so if you want to know about light, right? I think I was telling you this before. In my garage, when I do high voltage and I take a DC flyback and I run it from a ZVS, you get that distance, right? Well, depending on which DC flyback you get, you're able to get more voltage and amps out of it, right? So some of them go real thin, you get a little purple out of them. Some of them go real hot, you get white out of it. When you start rotating and spinning on it and then heat up the actual like spinning object. So I took a hole saw and hooked it to my drill, about that big. I took a ring on the outside of it, right? Negative on the outside, positive on the inside. Spin it. It makes a beautiful pink plasma. You know what I mean? So what's going on there is it's not enough to get white hot. It's not enough, not thin enough to stay purple because the metal on that hose saw is heating up a little bit. So it completely changes the color of the plasma coming out of it. So you can go to white. I've done pink, I've done purple. They get a little bit of yellow in there sometimes. Basically the rainbow. I do the cold voltage, I get the blue. Yeah, I get a lot of cool stuff. Yeah, it says cold voltage is blue, purple. It looks more blue to me. So, and that's just because my Tesla coil outside, I was running it. It was really cold outside. And then the wire that was, I had a rod down the center of my Tesla coil and a wire connected to it. And as you ran your finger along, it would light up blue. And it was the coolest thing in the world. So I wish I would have got that on tape. I should have. I think I even thought to myself at the same time, I should have gotten that right there because that would have been cool.
Yeah. Was that like some kind of corona discharge maybe?
Yeah. It was a corona discharge. So basically when you look at Tesla's X-ray that was safe, he had to be using cold energy. So in a vacuum situation, you may be able to pull that tube in there and pull cold energy out of it and see what you get. You know what I mean? Because it is basically it's a radiant energy. So you should be able to make an X-ray out of it.
Makes sense. They're using hot energy to do the X-rays now, right?
Yeah, basically. Radiation.
And we already know that using cold energy through something like your system or a couple other people's who've demonstrated online where, you can put your finger in the water and it's conducting electricity through the water, but it's not shocking you.
Yeah, not one bit. So hold on a minute. I'll just show you the pink. Now, I think a lot of people think I'm just talking about a tiny little bit of voltage. I'm not. Yeah, it's got it. There's so many videos on here. There it is. Try it and find out, huh?
Why, certainly.
I think you guys can enjoy it. Here you go.
It's
Here's how
all
to do
pink.
it, and it's pretty simple. Have fun. Just want to show you guys how to make a ring of fire, a ring of plasma with a couple simple tools. All you need to do is get your ZVS set up here with your flyback. Okay, and all you're going to do is you're going to put, this is an aluminum ring. You can use steel. Okay, it won't matter. Or copper. And then you're going to take a hole saw and your drill. Okay, and all you're going to do is you'll end up centering up the drill. Make sure you tape off the light here, okay, so you don't get that in the background because it makes a very bad image. Then you're going to take your wire here. Mine's all kind of funky hooked up to this big old cord that comes across here, okay? And all you're going to do is you got your negative over here. This will be your positive. As you hit the drill, okay, just place that on there as you're holding the drill. Now, pull the drill out before you stop it. Okay, because you'll get a little bit of a shock depending on how much your ZVS is going because there's a lot of static going on. Okay, put that right there and make a ring of fire, and I'll show you how it looks.
That's pink. Not quite white. You see a little bit of purple in there?
Wow. Yeah, that's cool.
By the way, let's look at how ridiculous this is, right? So, right before it starts, look at that. I'm already arcing over to that ring. It almost looks like I'm just setting fire to it. And then look at that. Boom, right away. That coax cable, by the way, those things are perfect for running high voltage. I love those things. Yeah, we'll just turn off the annoying sound. That's cool, though. Anyway, yeah, old man Bill's plays with a bunch of high voltage in his garage when nobody's looking. Oh, man. Dielectric orange, hence why it's purple. Yeah?
Interesting.
Did you see pink in there, Ben?
I did. Thought I did.
Oh, yeah.
Like a magenta almost.
Well, it's basically just, frequency and energy hit a magnetic field and they start creating energy. That's it. And the reason I tell you guys to pull out the drill, I got the shock of a lifetime in there from static electricity because of all the buildup on it. It literally, man, when you got broken parts like motors and stuff, you're going to be throwing out some static electricity. It shocked me good. So, good rule of thumb, always pull out before you're done. So, high voltage, that is.
I wasn't sure where you were going with that at first.
I had a guy who commented on the video. He was laughing about that.
Oh, yeah? That's funny.
Oh, I told him I got 5 kids, man. I know the price you pay. Oh, it's so great. Yeah, he got one hand in his pocket. But with a one-hand rule. Or it's called in my garage the pocket pool rule. You got something else going on in there if you got to get in there too much. Oh, that's funny, man. So great.
Nathan puts what is it, a tie around the doorknob of his garage.
He said, put a tie around the doorknob.
Don't come knocking when this garage is rocking.
Oh my. Oh. What's going on, Mike? We're sharing some stories about getting shocked. I'm sure Mike's got a couple of those.
Hey, Mike. Oh, that's funny.
Ooh, hold on. Give me a second. I just pulled something up, guys. It was there's a bunch of information on that device we were looking at earlier.
Oh yeah, you found some?
So sorry, it's just taking a minute to load up here. There's like a whole thing. Hold on, let me share the screen right here. Oh yeah. You know, I'll put a link to this in the chat. We'll just take a look at the pictures for right now. Kind of showing what he was thinking about doing there and stuff like that. Huh. That's going to be an interesting read for everybody. Let me see. He has all kinds of equations on there. He did a lot of work with it. So that's going to be a cool read. Oh, absolutely. Hold on. Let me I'll stop sharing real quick and I'll put the links in the chat. So give me just a second, guys. There's two links here. And I clicked on one of them. So here's one of the links here. And there's the other link right there. Yeah, I'm going to definitely save the links and I'm going to look at it and then maybe we'll do a whole video on it once I get it figured out. Maybe, you know what I mean, see what they did, then see what we're going to do with it. So, yeah. But there you go, guys. Hopefully that helps everybody out, man. That's really cool. So, all right, Mike, give me 1 second. Let me, there you go, Mike. I sent the link for you. But yeah, that's pretty cool, man. They have a lot of experiments that went on with that. So that's going to be really interesting, guys. So I want to know what he did with the center, if he put any energy in it.
Yeah, maybe it gives some more details of how he constructed it and what kind of results he got from it too.
Yeah. Oh man. I'll have to in the video description later, guys, I'll drop both those links in there. So we have them for posterity because you may not see them in the chat or be able to copy them or whatever. So I'll make sure I do that. But that way everybody has it. Everybody will be on the same page when we start doing this. Yeah. So let me just show you guys real quick. Sorry, it'll take a minute. Man, he dropped off and left a little while ago, didn't he? You said it was Elias? I never can pronounce names. Right here.
Yeah, Elias.
Yeah, right there. He's got it. He's the one that sent it to me. I just want to give him credit for it. Thank you very much. I really do appreciate it. By the way, he sent me a bunch of stuff, man. It's hard to go through it. There was like 40-something PDFs in there, man, and I've been reading as fast as I can. I still haven't gotten through half of them.
Yeah, this guy we'll be talking about something like that's extremely rare, and this guys will be like, he'll come on chat and be like, "Oh, I got a paper on that." So that's pretty cool. Much obliged. That was awesome.
Yeah, we appreciate it. Thank you very much, man. There he is. He popped back in. Yeah, there's some cool stuff in there, man. He's got a lot of cool PDFs in there and stuff that you just don't find everywhere. So, yeah.
Definitely a treasure trove.
Yeah. So that'll be cool, man. We'll be able to compare notes and see what we get, because I don't know that they're going to run the same type of energy we're going to, but it's definitely interesting to see what he saw about all the magnetic fields and then what materials he used to build it. You know what I mean? Maybe there's a few more details of how he put it together. Yeah, Joel's awesome, by the way, on Don Smith. Have you watched any of that, Ben?
I have not. I've seen some of Joel's work, but I haven't seen his latest PDF or anything like that.
Yeah, Joel's a really smart guy. Okay. We had the opportunity to have him on the Fringe think tank once, and everybody wanted to talk to him, man. So I'm going to ask him if he wants to do it again. But yeah, he's working on Don Smith right now, and I think we're going to have to hit him up on that too. So we'll see what's involved. Maybe while this other one's printing off, I can wind some coils for the Don Smith. I think that's pretty cool, man. Yeah, we'll do that. Yeah, everybody loves Joel, man. A real humble guy too, man. One of the most awesome conversations.
Yeah, I think if I'm not mistaken, he might have dropped by on my chat once when I was streaming.
Yeah. Well, he has, you know what I mean, a whole bunch of stuff in there. The peg cell is what I like to look at. He's doing Don Smith right now. He goes through, he has a whole notebook full of stuff, of information on different things, and he likes to read them every once in a while. So it's always good when I'm working in the garage to throw it on and see what he's talking about for the day, because he gives a lot of valuable information. Like, he did the radio signal with him once. So he takes this half coil. He takes another half coil, and he said as long as you run the top half coil, the bottom half coil will be able to be your ground, right? Then you can run a coil twice that size, and on all the other outside ones without a connection, and they'll pick up the frequency. And I thought, man, that's really cool. It's right into what I'm doing with quarter waves, half waves, and Tesla coils. So right in the wheelhouse of where we are. Mike, what's up?
Hey,
What's
going on? Freaking ice storm here.
Oh, wow.
Gee, ice and rain, and we're getting everything. Yeah. I did an experiment today. I was trying to make my own piezo transducer.
Okay.
And I'll describe basically the details in a second. So I got the idea from ChatGPT. So I got PVA glue, the Elmer's PVA glue, and I was going to mix Rochelle salt in with the PVA glue.
Okay.
Well, lo and behold, try to follow me with this. The Elmer's glue basically separated the water that was in the glue, expelled the water from the mix, okay? It shriveled up into a ball and lost 10 degrees in temperature. It's super cooled.
Really?
Yep.
Wow. That's cool.
endothermic reaction.
Okay,
Yeah.
hold on. Let's be very specific about this. This is just white Elmer's glue?
Yeah, the see-through, washable Elmer's glue.
Okay, and then you put Rochelle salt in there.
Yeah, so the mix is 50 to 50-50. So 50% of the glue and then 50% of the Rochelle salt. You pour it in, you start to stir it up, and what happens is the reaction almost happens instantaneously. Any water that was in the glue gets separated from the mix. Okay, as this is happening, the thing cools down by 10 degrees. I had the heat, um, the temperature laser on it, the thermal laser. It dropped 10 degrees. It's dropped, yeah, like less than 10 seconds.
Man, did you get it on
Bro, that's
video?
insane.
Yeah, I'm gonna work with the experiment again. Maybe make some videos on it.
Yeah.
But here's the kicker. Here's the kicker. I wanted to make a transducer with it. So I took 2 pieces of copper foil, put one on the top, one on the bottom, and then on the table I had aluminum foil. So not only did I get an endothermic reaction, it also created 0.6 volts at 30 milliamps.
Because it was in the energy transfer from getting cold?
It was collapsing. I was drawing in negative energy into it through the crystal.
All right. Elmer's glue and Rochelle salt. I am going
Yep.
to be at the store later.
So
I gotta see it. And you said you put it on aluminum foil?
Yeah, so I put the aluminum foil on the table just so I wouldn't make a mess on the table. Then I get a copper foil or the sheathing that's used for roofing and stuff. Cut 2 squares, say 2 by 2. Okay. So after I made up 2 little balls. They basically shrunk up into a ball. Put those on the first piece of copper. Then I took the second piece of copper and put it on top. So when you put your voltmeter, put the negative on the foil and the positive on the top plate. I was getting 0.6 volts at 30 milliamps just from that reaction. Now, the thing is, it has a half-life. When all the water gets extracted from that mix, because it's pushing the water out, drawing the negative energy in through the crystal, which is causing it to cool down. After all the water is pushed out of it, the reaction stops. So it's like an endothermic collapse. Because when I did the first experiment, I decided to grab it with my hand and go, holy crap, this thing's cold. So I did it again, put the temperature gauge laser to it, and it went 10 degrees below ambient. So
Sorry, I was trying to say my mic's. What I was going to say, it's always interesting when things go cold, how they produce that energy in there, and it stays in there and then dissipates, right?
Yeah, as soon as the water completely dissipates from that ball of Rochelle salt and the PVA, the reaction goes away. So I still have it. I'm going to take some readings on it later and see if there's still voltage going through it. But what really got me was the temperature thing, why it dove in temperature 10 degrees. That's a pretty drastic change. And it was not like I was using like crazy chemicals. I'm just using off the shelf Elmer's glue.
No, I know. That's why it's so cool because the stuff when it was done and it hardened back up. Were you able to use that?
Yeah, like you could actually, after it hardens up, you could actually cut it up into slices and make a transducer with it. So I
Can
might
you
take
really?
those balls. Yeah, so I'm thinking of cutting them up into thin slices, put them between 2 copper plates, and see if I put pressure on it, do I get a voltage? So right after the reaction started, yeah, the more I pushed on it, the more power I got out of it, the more mechanical stress you put on it. Pretty interesting. And I was like, I wasn't even looking for this reaction. It was like, okay, I'm going to get PVA glue, get the Rochelle salt, and I'm going to make myself a transducer DIY style, right? And then this happened. You know what I mean?
Yeah. Oh, wow. Okay, hold on. While you're here, Mike, I wanted to show everybody your video, if you don't mind, on your cells that you just made, the little ones.
The crystal cell, yeah.
Yeah. That way you can kind of tell people what's going on it, because I think it was so cool.
Yeah, this is nothing new, this cell was originally designed back in the 1800s to run the telegraph, because at that time they were experimenting a lot with battery tech. And they found when they mixed alum and they put it around a reactive metal such as like magnesium, that you get voltage. And the best part about the alum is it's not a galvanic reaction that's going on there. And because of that reason, magnesium doesn't deteriorate.
Nice.
So I found on Amazon those graphite ingot molds. They're 2.5 by 4 inches long, and they're about just under 1 inch deep, which gives you enough room to fill it up. It's super easy to make. Like, you don't have to be a rocket scientist to make it.
Welcome back
and
to research. It is set.
Yeah.
Well,
so,
Nick, if you don't mind.
Yeah, go ahead, play it.
Yeah.
And I decided to do a little follow-up video on my crystal battery cell.
Okay, hold on real quick before I do that. Let me.
I did my rendition of my own version of the Bendini crystal cell using alum. So I got them hooked up, and I wasn't too impressed with the power of the cells. So what I did was I just let them sit for a couple of days. And at that point, they were really saturated with a lot of water. So now the crystalline structure is now formed, and I'm able to get actually better voltage out of it. So when I hooked it up originally, it's gone down a little bit because I've been playing around with it. Before we get into that, if you haven't subscribed to the channel, bottom right-hand corner, and also at the end of the video, give me a thumbs up. Also in the link below, I have my links for my Patreon and my PayPal donate, and also you can subscribe and be a member of my YouTube channel. You can get all the exclusive videos there as well. So, so when I originally hooked it back up after a couple of days, this cell here was hitting 1.94 volts, and this one was hitting 1.6 volts. They'd gone down because I've been playing with the LED light, but yeah, it showed me a positive result. I'm just going to kind of show you here. I'll hook it up. I got 1.6, 1.7 volts in that cell. And this cell here, I got 1.57 volts. So it went down a little bit because I've been playing around with it for a bit. But after a couple of days, I hooked up the voltmeter. That guy was almost 2 volts, and this guy here was 1.6 and change, which is pretty good. So I squirted him with a little bit more water. Now I know the crystal structure is now formed and creating that matrix where the power can actually travel through. So I'm going to hook up the LED light so you can kind of get an idea of what kind of power we got here. Trying to do this. There we go. And you can see how bright that LED is. So we got some decent light. Here, I'll do a voltage reading of the cell combined. It's about 2.5 volts. See if I can actually pull this off. Get that probe there, that one there. What do we got here? That there. Oh, what am I doing wrong here? This would be positive. Hold on. Probably got this reversed. Why am I not getting the reading? Hold on. Bear with me for a second here. It's really hard to do this one. You got one hand.
Gotta buy you a tripod, Mike.
Here and here. There we go. 2.51 volts. So the two cells are giving me 2.51 volts, enough to power the LED light. Why is it going down to the short on me? Oh, that's why. I had these hitting each other, and you can't do that. It actually shorts it out. Because this is actually your positive, the graphite ingot's the positive, and the post is where the magnesium's hooked up to, and that's your negative. So if I put them together, it'll short out. See how it shorts out? So yeah, it's working really good. See how it shorts out when I touch each other? So as long as you keep them separated, you got power. So I'm pretty happy with the results. I'm going to work with this more, maybe make a few more of these and hook them up, and then try to start charging up capacitors, batteries, etc. And maybe even hook up a pulsing circuit to it as well. So that's pretty much it. I wanted to make a short video just to give you.
All right, Mike.
Yep.
That was really cool, by the way.
Yeah, how long does the battery last?
Until the water basically dries out. So it could be like 24 hours. So like just spray them once a day, and you'll make continuous power.
Yeah, you just need to just resaturate it, huh?
Yeah, just like when you water your plants in the morning, water your cell.
That is so cool.
By the way, I just want to say Robert Murray Smith. I watch that all the time.
Yeah, he's good. Yeah,
I like him.
I'm a big fan of him.
That's pretty cool, Mike. You over there with water and crystals and already making energy out of it?
Yep. And it's all solid state. It's alum is basically a pickling agent, so it's not dangerous chemicals at all. Magnesium's pretty widely available, and graphite you can pretty much order on Amazon or AliExpress or whatever. So the parts are very easy to get, and these cells will last for years. So initially, you have to spend some money to make it, but then after that, you got usable power for many years. So there's your free energy right there. And water, just get it out of your tap. Or put them outside in the garden, or put them in a flower pot, and every time it rains out, your lights will turn on outside. You could hook up a whole grid of lights.
Interesting.
Yeah, some DIY things for when you're out in the middle of the forest and you find some and stuff and make something that works. Not that you can
take it on. Well, you could take it on the road if you're like an adamant camper like I am. I love camping. You could take stuff like this on the road, have a whole, say, like a whole stream of LED lights, and make a box of these crystal cells. Bring it with you, and you could have free energy to run your lights at nighttime while you're camping. You don't have to be on the grid.
Well, yeah. I don't think people understand this. If you took a paddle wheel and hooked it to a generator, right, and you wanted it to run, all you had to do is take a hose and find a water source, suck on the hose a little bit, get the water flowing, and then put it right over that paddle wheel. You make a little bit of energy for light all night long.
Yeah, like there's like a lot of small streams and stuff. What you do is you get a paddle wheel, like you're saying, make a framework so it'll sit in the water but have the wheel halfway out. And if the stream is moving, just dunk it in there, and boom, you got your free energy right from the river, right?
Yeah, you could do it right from the river. Or, like I said, you could do it. I can drain a pool and do it. Like You put the hose in the pool, you suck on it, and it creates suction in there, and then it always feels like it's an imbalance to the water. So to
Right.
continuously shoot the water out, so it just goes right over the top of the paddle wheel.
Yeah, exactly. Yeah. It's just you got to look at different ways of doing things, right?
Yeah. Well, it also makes a cool thing for your garden. I mean, think about it. You want to run lights out there for your garden, you need a little bit of energy. Doesn't take much to put a couple things in there to convert it, right? So you just put a little paddle wheel in there, makes a little garden thing, but then you get lights all night long.
Exactly. Yep. We just got to rethink how we do stuff. Be a little bit more creative, right? So yeah, hopefully people will try that little experiment. It's obviously, you know, it's an endothermic reaction because the temperature is going down by 10 degrees. That's a huge jump in temperature change.
Oh yeah, yeah. Yeah, definitely going to try that. I might have some Elmer's glue at home. Yeah.
Yeah.
I got to look in the junk drawer and see what's in there. You know what I mean?
Yeah, exactly. Yeah, it's the see-through stuff. It's the clear see-through Elmer's washable glue. Yeah, that's what it is. So you just do 50-50 in the mix, and the second you put it in, it'll start globbing together. And as it's globbing together, all of a sudden, all this water's getting expelled from it. It's getting pulled out. And as it's doing that, the temperature is falling.
Yeah, I got to try that. Anything that gets cold, man, and puts off any energy, I like to see it. See what's going on.
Not a lot. It's not a lot of power. It's like 0.5, 0.6 volts, but it's given about 30 milliamps of current.
Well, hey, it's still something.
Yeah,
you know.
And I'm talking like, you know, the size of the ball when it was done was the size of a quarter. That's it.
Really?
That's how big it was. Yeah, tiny little thing.
Now, have you tried the reaction while it's compressed to see if it does a flat plate?
Say that again.
So say you compress your two pieces of metal together, and then you put it in the mixture, maybe take a syringe or something, you know what I mean? And put in the glue while you have the salt pinned.
Oh, I see what you're saying. Yeah, it would still work.
Would it form flatter? Is what I'm looking for.
No, it basically collapses on itself. So it will go from the dish, and all of a sudden it'll just coagulate into a ball.
So you say cut it. Can you do it with like an X-Acto knife and cut it in little slices?
Yeah. After it's done, the reaction's done, all the water's out. You can just cut it with an X-Acto blade knife, and you can experiment with that and put it in between two dissimilar metals, and then compress it and take a voltage reading.
Yeah, I got to try that because I like those little things that you can cut and get energy out of, and see if you can stack them. You know what I mean?
Yeah. Well, since you put a mechanical stress on the Rochelle salt, it should create a charge. Yeah.
Yeah, I'm working on that stuff right now. Some salts. I got some in water right now. You put them in the hot water. See if you can't grow the actual thing. And I got a Tesla coil connected to another one. The battery connected to another one. I got like a whole thing going on. One of the videos I'm making, Joe and I were looking at doing cells, so I wanted to show it on Saturday, see how far I've grown the cell and if I can impart frequency on it, stuff like that.
Yeah, that'd be interesting. Yeah.
Well, yeah, if we know what the frequency is.
Right. I was told you might want to pump in, if you're going to pump a frequency into that cell that you're making, pump in 30 hertz into it.
30 hertz?
Yeah, 30 hertz. You could do either pulse or square wave. I don't think it really matters. What it will do is it will actually arrange the crystals in the proper orientation. So.
Okay.
You can try that. 30 hertz. Yeah.
Interesting, Mike. I'll definitely try that. Yeah, I wanted to get something that I can just build a little circuit and run it. You know what I mean?
Yeah, exactly. Like I've been watching Lid Motor. He's been putting out some videos there. you can make a tiny little pulse motor like he has and hook up one of these, crystal cells to it, and it'd run for years.
Let me ask you something, Mike, on that pulse motor. What's the frequency you usually get out of it? Is it in hertz or kilohertz, or what are you getting?
Yeah, I'm averaging between 200 and 300 hertz when I get it running good.
Well, that's not bad.
Yep.
200 to 300 hertz. I'm way into the kilohertz.
Yeah, and that's why the battery draws such little powers, because I'm up in the 200 hertz range. So if you're pulsing power off the battery like that, cutting the voltage off the battery that fast at 200 hertz, basically your current goes to zero. You're fooling the battery. So that potential is not actually, you're just robbing it of the voltage. The current never leaves the cell or the battery. That's why, like when I run the Renegade, I'm only pulling 0.001 amps out of it. So it's like less than a half a watt. So that's why my batteries last for like 6 months before I have to recharge them.
Gotcha. Yeah, that's pretty cool. I got to build that machine, Mike. I bet you I have all the parts. What is it? Is it just a bunch of round magnets? Like I got some neodymium 52 round magnets. They're about the size of a quarter.
Yep, that's perfect. Yep.
Okay. And then the coils, are they built like a Bedini coil?
Well, it's not bifilar. It's just a single wire. I would start off with either 24 or 26 gauge. Either one will work fine. I usually use 24 gauge.
If I took the spool of wire right here, right?
Yep.
What are we looking at? 24 gauge? I could take this, and this would basically be the coil?
Yep. And all you have to do is get some welding rods or iron rod and make a metal core and shove it in there, and you'll have a very good coil with a very good reactance value in it.
So I got a question. So why not build the Bedini coil instead of just doing the single wire coil? Is there a reason?
You could. It's entirely up to you how you want to do it, right? How you want to use the power. Bendini used the second wire to actually use it as the trigger, so you would have another coil on the other side, and as it's spinning, it's creating power, and that little signal would be just enough voltage to trigger his MOSFET. Because he always used MOSFETs. I don't use MOSFETs. I use mechanical.
You spark gap.
I use spark gap switch. Right. I stay analog. That's one thing you always notice with mine. I'll do whatever it takes to make that thing completely analog.
Yeah, I don't blame you for that. It's easier to clean off the end of a spark gap than it is to keep replacing MOSFETs.
Well, if you get it tuned right, that spark coming off the spark gap switch, the discharge, is very, very small, and it will be a greenish blue color. But if you get it tuned just right and get the timing just right, that spark starts to go smaller and smaller and smaller, which is better for the motor. It makes the switch last a hell of a lot longer, right? Because it's not creating heat. And it minimizes the current coming off the battery. So the better you tune that spark, you get it down to a really, really tiny spark, your current coming off the battery should be almost non-existent. So I'm down to -3 decimal places. So if you're in the -3 decimal places, like 0.001 amps, you're getting it. You're getting a good reaction.
Very cool. Yeah, I'm definitely gonna have to do that. That seems like
you don't have to make you don't have to make it big like I did. You can make a small tabletop one, maybe like a 3 or 4 inch wheel. It doesn't have to be big.
Well, I wanted to do the 3D printed one you did. Yeah, I think that'd be cool, because then I can run it, you know what I mean, and run things off of it and see exactly what you're seeing in your experiment. You know what I mean?
And also, the woo-woo stuff that goes on with it too. And that's pretty apparent.
Is there any spacing that I need to worry about in between the magnets, or just as long as they're equally spaced?
Equally spaced, and I would not say like on a 4-inch wheel. I wouldn't exceed five magnets on the wheel. Reason for this, you want to, because you kind of know the speed that it's going to be rotating at. You want to keep it within the 200 hertz. So if you got 5 magnets, so per revolution, you're going to have 5 pulses.
Okay.
And then times that by the RPM. So I've always stayed within those parameters, and I got the best results. Some people like to put 1 million magnets on the thing, which is totally wrong. Right? If you got too many pulses, there has to be. Go ahead.
Sorry, the center's just a post, right? There's no motor under there; it's just a post.
Yep, you can use threaded rod, and put a washer underneath, and I use bearings all the time. I have a 3D printer, so I'm able to print wheels accurately that I can put a bearing in there. Usually I'll use the ceramic bearings because there's a lot of magnetic field in there, and you don't want any magnetic locking from the magnet and your bearing that's on the axle. So I recommend the ceramic bearings. Yeah, they cost a little bit of money, but overall, you're going to get a way better spin on it, less resistance.
And then you don't use a reed switch, do you? You got a different switch for that?
Yeah, I got away from the reed switch because I just blew up too many. But yeah, I used the 3D printer proximity sensor.
Okay.
I just completely isolate that from the rest of the circuit, so if something does go wrong, it's not going to fry your sensor.
Yeah, I got a couple of those.
Or Hall effect sensor works fine.
Gotcha. All right, I might have all the parts for it then. I just need to.
It is super basic. Like when you put it together, you're going to go, "Holy crap, this is easier than I thought." But tuning it, when you get it tuned just right, and you start doing some of the stuff we talked about offline, you're going to notice the effects.
Nice.
So, yeah, it's pretty apparent. I'm actually thinking of firing it up maybe tomorrow if I get some time for certain reasons. See if I can do something.
Well, I'll start a build on it. I got a couple things, we're working on.
Well, you got the video there. I got the schematic there, so you can kind of look at it. And then when you get the basic motor done and you got it running, then order a couple of those ceramic barium titanate transducers. Then hook 2 of them together in series, and then what you do is you hook those 2 up in parallel with the coil. So basically, one side's going to go to positive, one's going to go to negative. So when you look at it, it looks like a dead short.
Mm-hmm.
So that's it, and it's done. And then you'll have a 50% gain in power as soon as you hook those up.
Nice. Yeah, I'll do it in CAD tomorrow when I'm in there. I gotta make another device in there. So yeah.
Don't be afraid. Don't be afraid to make the wheel have some weight. Having a little bit of resistance on the wheel is okay. That helps with the timing.
Mm-hmm.
So yeah, it's a very easy project to make. I've made so many of them. I just don't even think about it.
But what 3 millimeter, 4 millimeter width should be fine. That's just put some weight on it.
Yep. Or you can do it solid or cut a piece of wood and make it into a wheel. You know what I mean? Or I've even used an old wheel from a walker.
I saw that.
Yeah. And that works great too because it has some mass. As soon as you get it powered up and it's flying, now you got some inertia behind it. Actually, it creates quite a bit of torque for a pulse motor. That one you're talking about, that thing had quite a bit of torque. I was very surprised.
Very cool.
Impulse motors aren't really known to be a torquey type motor. The other big mistake that everybody does with it too is they'll put the coil way too close to the wheel.
Mhm.
You basically want to put the coil the second that magnet starts locking onto the core, when it just starts pulling it in, that's where you keep it. You don't push it close. It's like mine is like almost a half inch away. So if you put it too close, it's going to cause resistance. It's going to cause cogging. That's what you don't want to do. There's one guy out there who makes excellent motors and stuff. His biggest mistake in the world, he puts the friggin' coil so close to the wheel that it's cogging like crazy. And as a result of that, then he wonders why his motor is always drawing over 1 amp of power. Because he's adding so much resistance in the cogging, right? So yeah, basically the second that magnet starts getting attracted to the core, that's where it stops. So right at that point, that's where you anchor your coil in place. So now when you're actually hitting it with power, it's not going to be it's not going to be affected by the core and slowing it down. And that will also contribute to the lens effect as well, right? So if you're outside that boundary, now your lens effect on that wheel is going to drop tremendously lower.
Yeah. Okay.
It's an ego project. Just like I said, you don't have to make a big one. Just make a small one. Get your feet wet and understand the circuit. And as soon as you understand the circuit, man, the sky's the limit. You can do so many experiments with that. And that motor you can loop, provided you use the method that I do. That's after the back EMF comes out, put one side to a ballast light, right? And then on the other side of the circuit, what you're going to do is put that back EMF to a full wave bridge rectifier, and from there dump it into a fairly large capacitor, and then as it's coming out again, put it through another full wave bridge. And now you can take that power and loop it right back into the battery. It won't know the symmetry of it. So
you just might have solved my problem, Mike. Holy crap! No, because I have a full bridge rectifier, and I have a full bridge rectifier, and I have it feeding back into the battery, but I don't have a capacitor, and I don't have another full bridge on the other end of the capacitor before the battery.
So bridge rectifier, capacitor, bridge rectifier, back to the battery, and that
then
way,
but I am getting the huge inductive spikes with that setup, so it's just not. Yeah, okay, that makes sense.
Well, actually, what you'll find if it's in a pulse motor and you just try to throw that power right back into the battery, it will actually short itself out.
It'll actually short itself out. So, yeah. So that method there actually prevents the shorting out of the battery. So there's other methods to do it, but this was the best one that I found, and I found it out on my own. And I'm like, cool, this is easier than the other methods that I tried, and there's no energy loss.
Do you think I could use a 0.15 microfarad Tesla cap, like a 2000 volt?
No, you don't want to use a high voltage cap. You want to use, say, DC electrolytic capacitor. It could be, 300 microfarad at maybe 200 volts. They're not very big.
Okay.
You can use
no,
one
I
of
have
those.
I have a cap kit. So you said 200 to 300 microfarad.
Yeah.
And then what was the voltage rating?
A voltage, well, you're going to have some pretty high spikes, so I would put probably at least a 200 volt cap. And then after that, then put it through the bridge rectifier one more time, because you got to make sure it's the symmetry has been changed, right? So
After that is done, the symmetry is completely changed and the motor will not know what that power, where the source was.
Interesting.
Because everybody tries to loop, I've seen so many guys doing pulse motors and they try to loop the thing without rectifying and changing the symmetry. And the second they put it on, the current goes through the roof, the motor slows down, and then their coil heats up. It's a complete meltdown. It's a complete meltdown, right? Well, this prevents that.
Nice. Well, that's the way to go then, man.
Yeah, and it's so easy to do.
Right on.
Now you can go a step further with it. So say you don't want to loop it, but you want to utilize that power. So now you can hook it up to a huge bank of capacitors and then put that on a timing circuit. And then you could pulse it into, say, a large bank of batteries. So you could be charging up, say, 6 car batteries with one tiny little car battery or a motorcycle battery. Right. Kind of picture that, you know, you're charging up 6 car batteries with one tiny little motorcycle battery.
Interesting.
Now you sound like Bedini.
Yeah, that's exactly what it is. Because Bendini's motor had 3 different configurations, and you know, a couple of them I already shared with you. So yeah, it's totally possible. But the thing is, you got to make sure the negative energy that you're pulsing into those batteries have been conditioned for negative energy. So that means you got to drain those batteries basically to almost zero. When that is done, then you pulse charge the negative energy into the battery to reformat that battery. If you don't do that, you'll eventually basically destroy the battery because you're trying to put.
I just watched a video on Bedini explaining just that.
Yeah. Yeah. So that's very, very important. Yeah.
I'm going through my cap kit and I don't have a voltage that high, but I do have a few 100 microfarad 25 volts, so I can just put those in parallel.
Yep, just be careful you don't wear glasses.
Yeah.
But you'll be pumping it right back into the battery again. So depending on,
I'm not too worried because the voltage that I was picking up from the meter with coming back, you know, after the rectifier was only like 27 volts. But it was, you know, enough to put back into the battery a little bit.
Sure. Yep. Trickle.
So, yeah, it wasn't a lot, but it was a little bit. You know, maybe not enough to close the loop, but enough to increase the efficiency, hopefully.
Yep. Yeah, you can add life to it.
So I appreciate the tips, man. I'm gonna try that tonight and let you guys know what happens.
Like, to me, looping a pulse motor is totally stupid to begin with because that power is what you want to use to charge other things. So I would focus on making a pulse motor super efficient.
Oh, really regarding pulse motors. Yeah. This is just for the lighting I'm doing, but yeah, regarding
even for a Jewel Thief, it's what I'm telling you still applies. So you can make a Jewel Thief put out the same power, but even be more efficient, right? Because the original Jewel Thief is designed to pull every single joule of power out of that battery.
Mm-hmm.
So yeah, you got to be careful; it'll drain it all the way.
Right. So if you can streamline how that power is being utilized coming out of the Jewel Thief, you can make the Jewel Thief run even longer with that battery.
Yeah, that's the idea.
And it's just the way people think. They want to make something run for nothing. Well, I'm sorry to tell you, that's not going to happen. We're at the point now where we're starting to figure out. Okay, let's get facts straight. You can't get a free lunch for starters. The energy's got to go.
You can recycle energy that's otherwise being wasted, and we have the I'm calling it the resonance relay. It's basically like an extension cable that Michelle recommended that I put together with a diode, just a high-speed diode. and what it does is direct the back EMF back towards the light source on the positive. So
Right.
it's
what diode is it? Schottky?
UF 4007, but I did
Yeah,
order
that's a
some
good one.
rare high speed ones.
Yeah.
Like a higher. Yeah, I ordered some other
You
ones.
might want to toy around with the Schottky diode.
Schottky, yeah, because it instantly doubled in brightness, and it didn't
Yeah.
change the current draw at all on the battery.
Yeah, well, Schottky will actually have a little bit of reverse leakage, so it's not like 100% directed, like say like a N4007
Yeah.
diode. That's what you want to start playing around with is the diodes.
Yeah. Well, I was going to ask you, do you have any recommendations that for diodes that might be able to, capture more of that, not leak? Because I have a feeling the UF 4007 is leaking still some of it.
Probably is very small, but you might, if you have enough money to dish out, I would start experimenting with some germanium diodes.
Yes, Michelle actually has a germanium diode that he ordered off of eBay. I am going to be looking for some. I'm not really sure where to start with looking at those. So I'll have to talk to him about.
Yeah, you might want to toy with the ones that they were using for the old crystal radio sets. I'm offhand. I'm sorry, I can't remember the number of the diode, but look online. Type in crystal or like turn of the century crystal radio sets using germanium diodes, and see what value they're using. And you might want to start there.
Gotcha.
Because the Jewel Thief runs at a very high frequency, and the germanium diode that you use for a crystal radio set will be very similar to what you want to use.
Yes, and I also do have a piezo. I'm not really sure if that could be hooked up in some way to amplify the signal.
So to your coil. So the main power of the coil. So it'd be the longest wire. You're basically going to take the piezo and short it out with the piezo.
You're going to come again?
So you take your coil wire. So you got one side of the wire, connect that to your positive, and then the other side of the wire on the coil connected to the negative. So you're actually making like a dead short. And that's going to give you a woo-woo power.
Is that on the output of the coil? Or before?
No, on the coil itself, directly connected right to the coil. One lead to the negative and one lead to the negative or positive, and that's it. Short it right out with the piezo. So I would do it.
Which channel to put it on, because I have two different channels I could put it on.
Well, on the Jewel Thief, you have like one wire that's only like 10 turns. And I think the other one's maybe like 20 turns, if I'm not mistaken.
Yeah, so the way we have it set up, it's the bifilers method is you have the start of one channel and the end of one channel connected by the power rail on the battery. So it's connected directly to the positive terminal on the battery. Then the other two wires are the positive and negative that go into the base of the transistor.
Okay, so you want to put it on the longest or the most windings. The most. Okay. Yeah, the one that has the most windings. That's where you want to hook up the transducer.
Okay, so probably after the energy goes through the coil and is coming out of it, then.
Right. Yeah. It's the one just before it goes to your load. So just basically short it out between your piezo. I would do with alligator clips first. So start the system up, get it running, have one side hooked up to the transducer to one end of your coil. And as it's running,
if it's the positive or the negative?
It doesn't matter. It doesn't matter. It could be positive.
Do you recommend that I hook this up before the Jewel Thief circuit or after between the load?
Between the load. Yeah.
Between the load. Okay.
Yeah.
So just short it out there.
Yeah, short it out there. So start it up, get it running, okay? And kind of monitor how much voltage is coming out, or you can see it visibly with the light. And then when you connect the other side to the other end of the coil, that light should go twice as bright.
And do you recommend hooking up the piezo before or after the diode?
Before the diode, it should be basically right piggyback with the coil.
Okay, so before, so right after the Joule Thief circuit, before the diode is the piezo, then it goes the diode, and then the load. Okay, I got it.
Yeah.
And then when I briefly tried it before, but I hooked up both sides in parallel, and I don't think that was going to work.
Well, no, you like say the positive of the coil, hook one end of the piezo to it, and then the negative of the piezo, hook it up to the negative side of the coil on the other side. So it's like you're dead shorting it. Some people put it in series. Yeah, it works, but not as good as putting it in parallel with the coil.
Okay, maybe that's what I did. Maybe I put it. I tried it once. I tried it very briefly, so I'll try it again tonight, and hopefully we'll get some results. But
yeah, do it with the alligator clips. Just hook one end up, and then as it's running, then hook up the negative side, and that light should go twice as bright. The second you do it, it's an instantaneous reaction.
I also tried putting a diode on the negative rail of the load too, but I didn't see any results. Whether it was speeding or slowing down or not, the battery. I didn't monitor it long enough.
It's either that or just throw it into a full wave bridge, because when you're pulsing it like that, it's a modified DC pulse wave, which basically can emulate an AC circuit. That's why you're able to light up AC light bulbs with it, right?
Yeah, and that's why I can pick up the AC current with the amplifier.
Right, and it's also a hybrid too, that you can actually dump it into a battery too. So it's one of those types of energies that it's a hybrid between AC and DC. It's a pulse DC. So yeah, it gives you flexibility whatever way you want to go. If you want to stick to an AC type load, or if you want to dump it into the full wave bridge and make it a pure DC load channel out, that you can do either or. That's the beauty of it. Because like later down the road, that's what Tesla was actually doing. He solved all the problems with AC. AC to him was basically really only good for long distance transmission of power. But when it came to smaller devices, obviously, using battery power is good too, right? So, just him and Edison just had a different perspective. But it all depends on the application that you're using the power for, right? Are you transmitting power, or are you just powering small devices? So each power has its pros and cons for each, right? It's like a TV. It's like, okay, you plug the TV in the wall, you're using AC, but meanwhile it only takes 12 volts to run the TV. Right?
Yeah, that's bad.
It's totally stupid. We're totally ass backwards.
Yeah,
right?
Pretty much.
Like you can take a car battery and you can run your TV probably for about 2 weeks before that battery will run out of power.
Basically, yeah.
Yeah. Because like the TVs are so efficient now, but you're wasting more power using the AC channel coming out of the wall, converting it or inverting it inside the TV circuit, and then it just converts it to 12 volts. It's like total ass backwards.
I don't even use my lights anymore most of the time unless I absolutely need it to be extremely bright for some reason. I use the battery. I use the battery, the Lightning Thief, and the 40-watt panel I have, and the lumen lamp.
Yep. Like heavy appliances, say like microwave or your oven, or like even a refrigerator now, they're making those things so damn efficient now. Like mine's only drawing I think it's only like 180 watts for my refrigerator. 180 watts. That's nothing.
Yeah,
compared to what they used to be. Yeah, it's a fairly new GE refrigerator. It's it doesn't have all the bells and whistles. It doesn't have an ice maker in it and all that kind of stuff. It's just a basic refrigerator. The thing only draws only about 1.1 amp at 120 volts. Nothing. super efficient. So you could even run that off an inverter for like a week. You know what I mean? Like, it's not really drawing that much power.
Yeah, it kind of makes sense to have DC in your house, right? Do a
Yeah,
converter
like
and just
all
run
your
everything.
lighting, you could go all to LEDs, like just tear out all your wiring in your house, rewire everything in DC, and you're completely off the grid. And just make crystal batteries the size of car batteries, and you're good to go. Just add some water every morning, and you got power.
Well, yeah. You know, it would help to have a DC circuit in the garage just in case. You know what I mean?
Yeah, backup. Yeah.
Interesting. Tesla's work led him to AC, and now we're going back to DC.
Yeah, well, you know, AC was designed for long distance transmission, right? That was the whole point of it. So,
well, no, I'm just saying that the evolution of the technology, now we're focusing on DC as the solution. It's just ironic because it's the solution now.
yeah, because we now we're in the modern age, well, supposedly, but you know, our power transmission is to the point where everybody's got power, and it's somewhat it's just the times have changed. Now we're worried about the environment and all these power lines. How many birds get killed on the power lines every year? It's bad for the ecosystem, and they've made the power lines basically into a parasitic antenna, which is extremely harmful to the human body. Eric Dollar talks about this all the time. It's like he says, it's not even a power line anymore. It's a giant friggin' parasitic antenna. He says it's like sheer evil of what they've actually done to the power grid system. So parasitic and bad for the environment. It's killing the bees and screwing up the birds, and causing cancer if you live near one of those power lines and it's not operating properly and creating all this parasitic radiation. Who knows? You probably get sick from that. It wouldn't surprise me. So I think we're personally, I think we're a lot better than that, and I think we should really evaluate how we make a centralized power system. To me, I think the centralized power system is severely flawed. I'm very big on decentralization of power, because now if you're able to generate your own power at home and there's a big ice storm outside and a tree knocks over a power line, you don't have power for several days, maybe several weeks. If you're off the grid or running on a decentralized power system, who cares? Tree falls on the line or whatever, it's not going to affect you any, right? You're more self-sustaining. Or if there's a tornado event or a hurricane or natural disaster, you still got power as long as your generator in your house works properly.
Yeah.
So that could be a matter of life and death situation. Like, look at the people in Florida, right? How many hurricanes that they have had to go through there in the last 25 years.
Yeah, there's always one going through there, man. There's always something going on. And no matter which state you're in, they get their flaws. At least that's what I've found.
Even our East Coast, right up in Newfoundland and stuff, they get some nasty friggin' storms up there. I'm telling you, like flooding and high winds, and we'll get the leftover of the hurricane that hits the eastern seaboard if it goes up through the Georgia and the Carolinas and all that, all the way up New York State there. It eventually hits Newfoundland, and they get a nasty whip of it. And they had some major flooding there. I think it was last year. They had some major flooding there in the high winds. Nova Scotia and Newfoundland, they get belted pretty hard. So, but if you're on a decentralized system, like I'm totally advocating, I wish eventually that's the direction we're going to go. They just have to reorganize the whole power energy system, that we use today. I think it's, what we're using now is way outdated, extremely outdated. How about if we get a solar flare? We had a solar flare hit northern Quebec. I believe it was 2012. It was a microburst from the sun. It actually wiped out the power grid in northern Quebec, and they didn't have power there for about 3 months.
Oh wow!
Yeah, so it was like a mini Carrington event that happened in northern Quebec in 2012. Never really made the news though. That's the kicker too. They didn't talk about that much, which would open a lot of people's eyes. Like, okay, how safe is our system if we get hit by an EMP blast or get hit by a solar flare? And the last couple of years, our sun's been super active. That hits our power grid. We're going to be out of power for a prolonged period of time. Maybe to the point where things are going to get dangerous. Say you got a power grid, right? And you got a nuclear power plant. All of a sudden you lose your power. You get an EMP or a solar flare that knocks it out. Well, guess what? Now the water pump system that cools the nuclear reactor doesn't have power. So now the nuclear reactor overheats and you have a Fukushima. So you got, say, 100 or 150 nuclear power plants in the US right now. Could you imagine 150 Fukushimas going off at the same time? That would destroy. That would be catastrophic for the planet.
Yeah.
Catastrophic, like to the highest order. Like people don't realize how unsafe or there's no redundancy in the power grid system if we do get hit. And it could happen at any time and we can control it.
Yeah, it'd be good to get power in your own house, that's for sure.
I think eventually, if the way things keep going, that could happen, so if society breaks down and, global trade gets screwed up like it seems to be, it's going to get pretty bad, I think, by the summer this year for everybody in North America. I think it's going to be a very bad situation.
I have no doubt it's going to get bad, but are they going to fix it so you get power at your own home? You know what I mean? I don't think so. They make too much money off of it. There's too much profit in it. So they always say that they're in a deficit or they have the money to upgrade the lines, and then the CEO turns around and gets like several $1 million bonus. And you're like, really?
Yeah, exactly. Yep, exactly. And we have the same problem here in Canada too. Like the guy that's the head of Hydro One here in Ontario, he makes $4 million a year. Doing what?
Yeah,
he makes $4 million a year. The CEO of Hydro One Ontario, he makes $4 million a year. Doing what?
Yeah, watching the water go by. Making little paper boats or something. I don't know.
He's probably in the Bahamas, or he's in St. Martin and on a beach somewhere.
Working from home. Yeah.
If
you ever set foot in the office or factory, he would probably be playing Tetris or something.
Yeah. Totally disconnected from everybody.
Oh yeah. No idea why something's going on, huh? I don't doubt it. That's funny. Hey, Mike, we've been going at it almost about 3 hours, man. I think it's about time to call it.
All right. Well, thanks for having me on.
Right on, man. Always appreciate it when you come on, Mike. Thank you.
Yeah, put in my 2 cents.
It's always a pleasure, Mike. Appreciate the advice.
Yeah, no problem, Ben.
Right on, guys. Hey, guys, everybody in the chat, I just want to say thank you, man. You guys have been awesome tonight. We'll be back on Wednesday for the Builders Workshop. And we'll see Mike on Friday.
Yep.
And yeah, it's been awesome, guys. I really do appreciate everybody, man.
Yeah, thanks, guys. Thanks, everybody.
Have a great night.
Good night.
Good night.